Let's take a ride. More to come in this marathon of John Michael Godier's Event Horizon.
One particularly ignominious solution to the Fermi Paradox is that humans simply have no idea how to look for alien civilizations. This could be due to misconceptions as to what evidence of alien civilizations would actually look like. We tended in the past to envision Kardashev Type 3 galaxy-spanning empires full of Dyson spheres and Shkedov thrusters moving entire stars around. But to do that requires a lot of energy. Indeed, Kardashev's scale is based on how much energy a civilization can harness. Trouble is, it may actually be a lot more complicated than that. It could be that doing these sorts of megascale projects and galactic colonization may neither be desirable to an advanced civilization or worth it. Instead, alien civilizations might be far more subtle, leaving very little detectable evidence of themselves. In recent years, this has led to the formulation of potential technosignatures we might detect that would indicate the presence of a civilization, but are now only just barely detectable with the instruments we have. This includes things like industrial gases and an atmosphere that do not occur in nature, such as CFCs, which could indicate a civilization is polluting its atmosphere, or alternatively, terraforming a world. This is only just becoming a practical method of SETI. But another is also now becoming practical. The idea that artifacts or probes of alien civilizations could be lurking within our own solar system. My guest envisions ways we might look for such things as we venture off this planet and explore the universe.
You have fallen into Event Horizon with John Michael Godier. Joining John on today's program is theoretical physicist Dr. Avi Loeb, the Frank B. Burr Jr. Professor of Science at Harvard University. Dr. Loeb has authored over 600 papers. He is the founding director of Harvard's Black Hole Initiative and also serves on the advisory committee for the Breakthrough Starshot Initiative. In 2012, Time magazine selected Loeb as one of the 25 most influential people in space.
And we're back with Dr. Avi Loeb. Now, Doctor, the idea is eventually to go to the Alpha Centauri system. And within that system is the star that's closest to our own star system, as far as we know, Proxima Centauri. Recently, this has been found to probably have a planet, Proxima b. Would this be a good target for Breakthrough Starshot?
Yeah, interestingly, Proxima b is in the habitable zone of Proxima Centauri, the star. The star itself has 12% or so of the mass of the sun, so it's a dwarf star. It's much fainter than the sun, and the habitable zone is much closer to it. It's about 20 times closer than the Earth-Sun separation. Interestingly, at that distance, Proxima b, the planet, is tidally locked. It faces the star with the same side at all times. So it has a permanent day side and a permanent night side. And the average temperature is, in principle, appropriate for having liquid water on its surface. So it could be habitable, although we don't know for sure. My daughter says that if we ever travel there, she would like to have a house in the permanent night side where she would sleep, and then her vacation home, the second house, in the permanent sunset strip that separates the day side from the night side, where she would have all of her vacations, because it's quite wonderful to have a permanent sunset all day long. And we simply don't know if it may have life on it, and we would like to know. So one way to find out is fly a camera next to it and image the surface to see if it's green, whether it has vegetation, if it's blue, whether it has oceans, or if it's yellow, just desert-like.
So you would have this permanent twilight area on the planet, presuming it's tidally locked to Proxima Centauri. So you would have this sort of zone, like an eyeball world, a zone of habitability on it where liquid water would possibly be.
That's true. And I should say also that this raises the possibility of detecting a signal from an extraterrestrial civilization, because it's possible to predict as the planet moves around the star, one side of it is illuminated, just like the moon is illuminated by the sun. One side is illuminated, the other is not. And as it moves around the star, you see different amounts of light reflected off the surface of the planet. And even without resolving the planet, you can monitor how its brightness changes. Now, if there is a civilization on it, obviously they would prefer to illuminate the dark side during the night. And they will redistribute the energy that is impinging on the permanent day side. They would distribute it to the night side. They would also distribute the heat, because the permanent day side is hot and the permanent night side is very cold. And so these effects of redistribution of heat and light can in principle be detected just by monitoring the radiation coming off the planet. And this is another way to search for artificial effects of other civilizations. One can search for pollution of atmospheres. One can search for photovoltaic cells that cover, for example, the permanent day side. And one can search for redistribution of light and heat across the surface of a planet.
So essentially, if a civilization developed on a tidally locked world, it could basically take control of its planet and mitigate what that causes and make more of the planet habitable, right?
Exactly. And we can detect a signature of that without even resolving the planet, because we would see that the light curve of the planet as it moves around the star is different from what we expect based on one side being illuminated and the other side being dark.
So you would, and I suppose there's also biosignatures there, because if you detected, say, the vegetative red edge, you would know that there's a biosphere at least on this planet, or other close by red dwarf based systems like TRAPPIST-1. Now,
that's right.
Yes, so there's multiple ways. You can either detect the biosphere or you can detect a civilization if it's there. There are several ways to do that.
Right.
Now, one problem with it, though, is that Proxima Centauri is a somewhat active star, it seems, as far as flares. What implications does that have on habitability for this planet?
Well, there is the fundamental question of why do we find ourselves next to a star like the Sun? The Sun is a rare star. The most abundant type of stars are dwarf stars, like Proxima Centauri, which is 12% of the mass of the Sun, or TRAPPIST-1, which is 8% of the mass of the Sun. A star like TRAPPIST-1 would live for up to 10 trillion years, about 1,000 times longer than the Sun. And so not only these stars are much more abundant, but they are much longer lived than the Sun. And so if you ask yourself, where are we most likely to exist? It would be, if you just assume that life is possible next to dwarf stars, you would say, well, we are most likely to exist near a star like TRAPPIST-1 in the distant future. But we find ourselves next to the Sun today. I mean, even though the Sun would burn up, it's roughly at the middle of its life right now. It will burn up when the universe doubles its age. And so the question is, why do we exist now next to a star like the Sun? And one possible explanation is that life is not so easy next to these dwarf stars, because they flare a lot. They have these eruptions on their surface that sterilize the planets around them. These eruptions tend to wipe out possible life forms. Moreover, the planets close to those stars, and you need to be 20 times closer than the Earth is from the Sun in order to be close enough to the furnace to keep yourself warm. As I mentioned, Proxima b is 20 times closer. And at these distances, you're much more exposed to the wind coming off the star. And so this wind could potentially rip apart the atmosphere, strip the atmosphere of the planet. And if there is no atmosphere to the planet, you cannot have liquid water, because water ice when you warm it up in vacuum, goes directly into gas phase. And so without an atmosphere, you would never have life as we know it. And so it's possible that the habitable zone near dwarf stars is so close to the star that the atmospheres of otherwise life-bearing planets was ripped apart, was stripped, and so you can't have life there. And that's why we find ourselves next to a star like the sun, where we don't have to be that close, where the eruptions are not as violent as dwarf stars show. I should say that there is a large contingency of the astronomical community searching for planets around dwarf stars. It's easier to find them because dwarf stars are smaller, and so if a planet goes in front of it, it blocks a bigger fraction of the light. Also, such planets tend to be on tighter orbits, and so it's easier to see them circling around the star within a reasonable observing time. And so there is this tendency of astronomers to go after planets around dwarf stars. But if you accept the idea that perhaps life is not as likely around dwarf stars, we should not look for the keys under the lamppost. We should look for the keys where we expect them to be.
Now, looking closer to home as far as technosignatures go, you recently covered the idea that Jupiter has been collecting objects, interstellar objects, for presumably billions of years, and possibly it may have picked up something from an exocivilization. What is it about Jupiter? Where does it accumulate these sorts of objects?
Well, that is a very interesting process. So if you imagine a sea of interstellar objects filling up space, they are passing through the solar system at different orbits, but every now and then an object passes close to Jupiter. So let's say within 10 times the size of Jupiter. When it does so, it gives Jupiter a small kick. And if the kick is significant enough, the object may lose energy to Jupiter and then get trapped in the solar system because it lost energy. So even though initially, to start with, it was unbound to the sun, after it gives Jupiter a kick, it gets bound to the sun. And that's a process of trapping an object. So the sun and Jupiter act as a fishing net that collects fish from interstellar space. And you can ask how many such fish should be collected? How many objects like Oumuamua, for example, should be within the solar system? Turns out that every about 100 years, an object like Oumuamua would be collected, trapped by the solar system as a result of the interaction with Jupiter. And there should be a lot of these objects. Now, after they get trapped, they could leave the system again because of the effects of the other planets. So the orbit is not necessarily stable. It usually survives for 500,000 years or so, and then the objects get kicked out again. But there is sort of a steady state where new objects come in, and some objects leave the system. And on average, you have about 6,000 Oumuamua size objects trapped within the solar system. Now, why is this interesting? It's interesting because these objects are here to stay for 500,000 years. And that means that if we find them, we can contemplate a mission to fly by them, visit them, or even land on their surface. So that would be a new way of exploring interstellar objects. Instead of waiting for them to appear and leave the solar system, and then you have to be on alert to send a mission during the few months that the object is spending in the vicinity of the Earth, which is it's nerve-wracking to be on alert at all times and just launch immediately as you see such an object. Instead of that, if you identify interstellar objects that are trapped in the solar system, you can take your time and visit them at your convenience within the next 500,000 years or so. And so the question is how to find them. So there are two ways to find them. One, if they pass very close to the sun, they can get evaporated and produce cometary tails. And then you can study the isotope ratio of oxygen in their cometary tail, and you can check if it's the same as objects that were born in the solar system. And you expect the isotope ratio of oxygen to differ from the solar system for objects that came from outside the solar system, because this abundance of isotopes changes from place to place within the Milky Way galaxy, depending on which exploding star produced the oxygen and how far you are from it and when was the explosion and so forth. And so if we see a cometary tail with an unusual abundance pattern, then we would know that this object perhaps came from outside the solar system. But another way to find out is to look at their orbits. And this is a paper that we wrote with an undergraduate student at Harvard, Amir Siraj, just last month. We tried to figure out what kind of orbits you expect these trapped objects to occupy. And what we found is that there are 6,000 bound objects, let's say, at any given time. But some of them are on very unusual orbits compared to the much larger population of solar system objects. So most of the solar system objects, for example, centaurs, this is a population of objects in the vicinity of Jupiter, somewhere between the orbital radius of Jupiter up to 10 times the orbital radius. Most of them are in the plane of the planets. They were born in the same plane where the planets were born, and they move roughly in the same plane. Those objects that are interstellar in origin, some of them cross the plane perpendicular to it. So they are highly inclined relative to the plane. And there aren't many centaurs with such orbits. In fact, there are none. And so you can search for objects with unusual orbits. And in fact, we did that. We looked at all the objects that are known from past surveys, and we found 4 of them that are highly inclined, almost vertical, to the plane of the planets in the solar system. And so these are candidates. These 4 objects that we identified are candidates for an interstellar origin. We don't know if they came from outside the solar system because you could imagine some violent process kicking an object that was born in the solar system into such an orbit. For example, if there is a passing star, it could kick some objects into such orbits. But at least we have candidates, and we can contemplate a mission to visit them or some additional observatories that will collect more data on these objects. And that offers a very exciting way of finding more objects like Oumuamua by looking at unusual orbits.
But these would be objects that we could study at our leisure because they're trapped in the solar system.
Exactly.
Now,
and I should say that 3 of the 4 were discovered just over the past year. So it's not as if a lot of them were known before.
So say we did go out there, we would essentially have a geologic sampling of the Milky Way galaxy because these objects could be from anywhere originally. But I guess there would be no way to tell exactly where they were from. That information would be lost, right?
Right. We would not know that. But what would be the most exciting thing to do is land on their surface and analyze their composition. And aside from figuring out what they are made of and inferring their structure, it would be very interesting to search for any signs of life on them. Because in principle, life can survive over 1 million years in the interior of a piece of rock. We know that some bacteria are very resilient, and even small animals called tardigrades can survive in space. We took some of them for more than a week to space, where they suffered dehydration, were exposed to cosmic rays, to ultraviolet radiation. And nevertheless, when they came back to Earth, half of them produced healthy embryos. So we can imagine biology surviving in the deep interior of a rock. And it's quite possible that if some of these rocks had life in them, that we could potentially dig into them and find evidence for life from another planetary system. That would be the most exciting thing to do, to basically break or drill through the rock and see if there is any signature of life coming from another location. Because if we find such life, there is the fundamental question, is it life as we know it, or is it different? And there is also the possibility that life was brought to Earth from another location. Every 100,000 years or so, an object like Oumuamua would crash on the surface of the Earth. So Oumuamua, as you said, passed within roughly a sixth of the Earth-Sun separation. But, if there are more objects flying by, every about 100,000 years, one of them will crash on the surface of the Earth. And if life in its interior can survive the journey, and it could potentially, because we did find rocks from Mars that were not heated by too much in their interior, then you could imagine that life could have been brought to Earth from another location. That really depends on how ubiquitous life is in rocks that are going to interstellar space, and we don't know that. And of course, there is this small chance that every now and then by imaging such an object, we would find evidence for some technological equipment.
In recent years, they've identified bacteria, microbes that are tolerant to just amazing amounts of radiation. It's actually more than what they would experience in space, in some cases. But they don't really know if that's an effect of them being able to dry out, and it's just by chance that they can absorb radiation like that, or if it actually, at some point, they might have been affected by, an environment in space and evolved that way.
That's right.
But now, with intergalactic panspermia, it's not just the idea that life itself could be seeded. There's also the idea that, when you look at meteorites that are associated with comets, you see lots of organic chemistry, including amino acids present in them. As I recall, the Murchison meteorite had them. And that shows that even if you don't have intergalactic panspermia, you still have the building blocks of life being delivered by exocomets. But in the time that we've been looking, since the days of Edmund Halley, we have never seen an interstellar comet. Do you think we should have? Should one on a hyperbolic orbit have passed through the solar system by now in the last few hundred years?
Well, in fact, that's the subject of a paper that we're about to complete with a postdoc of mine, because one way to probe the composition of an interstellar object is to find it passing very close to the sun. The sun will act as a furnace that burns up the object, releases gases that we can analyze spectroscopically using telescopes on Earth. And that offers a very efficient way of learning about the makeup of an interstellar object without the need of launching a mission that will land on its surface and drill into it. And so just burning up an object with sunlight is a very effective way of learning about the makeup. And we are estimating how frequently that should be expected based on the fact that we detected Oumuamua. And it should be a rare event, but not extremely rare. And it's doable in principle for us to monitor objects that plunge close to the sun. We were not aware in the past of the possibility that the likelihood could be substantial for such objects because we didn't expect many interstellar objects. But as I mentioned at the beginning, Oumuamua's detection implies a much larger abundance than we anticipated of such objects, and therefore offers the prospects of studying them in great detail when they get evaporated by the sunlight. And in general, this would offer a very good way of not only knowing the statistics of such objects, but knowing perhaps where they are produced, what are the nurseries of these objects. Now, we don't know if they're natural or artificial in origin. We ourselves are developing the technologies that would allow us to send technological bottles to the shores of other planetary systems. So we should expect some of these bottles to arrive to us. And they may contain technological equipment like robots equipped with 3D printers, for example, if they want to use the raw materials that they scoop somewhere in making artificial objects based on the blueprints from their home planet. Or they could include microbes if as a means of transferring life between their system and other systems. And of course, the origins of life question is not solved by arguing that panspermia may be responsible for life, because we still need to explain it somewhere else. One fact about life on Earth is that all molecules of life have the same handedness. In principle, the chemistry of life is symmetric. You can imagine life with both right-handed molecules as much as life with left-handed molecules. And that means the orientation of the molecules could be either way. These are complex molecules. But we find life to be associated just with one type of handedness everywhere on Earth. And one may wonder, why is it so? So a simple conjecture would be to say that, the one-handedness dominated the resources at some point and ate all other forms of life that have a different handedness. But that is difficult to believe if you can imagine some islands that were completely isolated from the rest and where life belonged to the different handedness. So one way to explain it would be to say, well, maybe it was brought to Earth in just one-handedness, and that explains why all forms of life on Earth have the same handedness.
Yeah, it brings up, an interesting question is that with ice shell moons like Europa, if we were to drill in there and find microbial life that was of a different chirality, that, was the opposite, that would essentially be a dead ringer that, this is completely independent life from Earth, right?
Right, exactly. Now, it's possible that we ourselves will never develop the technology that allows us to send to interstellar space the kind of things that I was talking about. For example, in order to send robots with 3D printers, before we do that, robots will replace human labor here on Earth. And we see that already. Robots are starting to replace humans in construction sites, and their share, together with artificial intelligence in the labor market, will grow rapidly because their development improves exponentially on a timescale of a few years. But it's not clear that our society will adjust to these changes because the robots and computers take away jobs, and the way society needs to adjust to that is to contemplate, for example, paying citizens an income floor that is unrelated to the work performed in the job market, because the workload will shrink as more and more robots take the jobs of humans. And you might imagine a new form of society where everyone gets more than the minimum they need and does whatever everyone wants in their spare time. And however, the rapidly growing technologies are already encountering some pushback through the nostalgia to the old world order in populist political movements. And it's not at all guaranteed that our civilization will move towards a more advanced technological future. We could be inspired to move in that direction by detecting signals from another civilization. But if we can endure the technological revolution of computers and robots, we might conquer the Milky Way galaxy. But if not, then our unfortunate societal future on Earth will provide a sober explanation to Fermi's century-old paradox. Where is everybody? The answer would be that civilizations, as soon as they mature to be technological, encounter instabilities or pushback or trigger catastrophes that destroy them, and they are short-lived. And as a result, we don't see many other civilizations contacting us at this moment.
And we must take a break. I'm joined today by Professor Avi Loeb. We'll be back in a minute.
Thanks for watching Event Horizon. If you're watching this during the premiere event, then say hello in the chat after the tone. If you're one of the people who are watching it post-event, then leave a comment. I'll make sure John reads them all. Remember, the AI sees all. Even you, zesty crab legs.
And we're back with Dr. Avi Loeb. Now, Doctor, you knew Professor Hawking, and he most famously would say that finding extraterrestrial intelligence might not be a pleasant thing. It might, in fact, be a frightening thing if it's something very different from us, like a machine civilization. What is your view on that?
Well, I think the last part is probably right, because we are moving in the direction of machines replacing biological life in performing many of the tasks that we want accomplished. The humans are not really suitable for travel through space. In fact, when people advertise the idea of establishing a colony on Mars, for example, they neglect one important risk, which is that about 1 in 10 cells in the human brain will be damaged by cosmic rays if you spend more than a year or a few years on Mars. And it's very difficult actually to shield humans against cosmic rays if they're on the surface of Mars, for example. So being on a spaceship is even more risky. And it's not at all clear that humans can survive for extended periods of time. And so it's much more natural to send machines without risking the lives of people that we know about. Moreover, machines like robots with 3D printers can reconstruct anything we find on Earth elsewhere using raw materials. And so that would make much more sense. And so the future of space travel, the future of our civilization, once the sun will boil off the oceans on the Earth in less than 1 billion years, or even before that, once we have a giant asteroid impacting the Earth the way it killed the dinosaurs, will destroy our civilization. Or even before that, we might have a self-inflicted nuclear winter through climate change or global warming, one or the other, a nuclear war, or changing the climate through industrial pollution. So either way, the only question is the time scale, somewhere between centuries to 1 billion years. We will have to move away from the Earth. And it's quite likely that most of the ways by which we move away from the Earth will be dominated by machines. And they could reconstruct life as we know it elsewhere, but they are much more resilient to the conditions in space. And the same may apply to other civilizations. And of course, from human history, we know that it's much wiser to first collect signals, collect intelligence about other cultures before engaging with them, because we know about the experience that the Native Americans had where America was invaded by Europeans. Most of these people died from diseases and other things, and it makes more sense to first listen before we speak, because we can figure out whether the other side has some hostile intentions. And the most prominent cultures on Earth often had a very strong military, and so one has to be careful that we don't want to suffer the consequences of engaging with another culture that is much more powerful than we are. And so I agree with Stephen Hawking that we should most of the time listen before we speak out. The problem is that we already spoke out. For the past 100 years or so, we've been transmitting radio signals and that are artificial in origin. And these are now at a distance of 100 light years. And there are plenty of stars within that volume that our radio signals reach. And it's quite possible that someone is listening right now to them. And of course, it's hard to stop these radio waves from moving out. They are already on their way. The best we can do is not to transmit too much in the future, not to announce our existence before we know what's out there. And so part of the collecting of intelligence about other civilizations is associated with SETI, with the search for signals or the search for messages in bottles, equipment that is swept into the solar system that we can examine before we engage in contact with another civilization. So I completely agree with Stephen that we shouldn't announce very brightly our existence. We should first collect information. As to whether they're more likely to be friendly or hostile, I have no clue. It's quite possible that wisdom establishes peace, that they realize that they have no risk from us. They are so superior to us that we are sort of like very primitive animals to them, and they would not be worried about us, and they would treat us nicely as pets. We have pets at home, and they're not as advanced as we are, and we treat them nicely. So it's not at all clear how they would behave towards us, but we can't know for sure in advance, and so we should be careful.
Yeah, and it could also be said people domesticate livestock too. So there's some things that aren't pets. But, I don't know that, do you think we could even hide Earth, though? Because Earth, even before the rise of our civilization, Earth has been a very interesting exoplanet for a very long time because of its weird oxygen levels and methane. that indicate there could be a biosphere here. So if there are astronomers out there looking for exoplanets, Earth is probably a really interesting one, and they've known about it for millions of years, possibly. So is the cat already out of the bag? Could we even hide our civilization or even our planet?
Yeah, I don't think we should attempt to do that, and I don't think it would serve. It would be a major engineering project to do that, and we should not be afraid of our own shadow, so to speak. We should develop technologies that allow us to escape from dangerous situations, and in fact, most of the danger is next door, here on Earth, from inappropriate behavior that humans exhibit relative to each other, going to wars, developing weapons of mass destruction, not caring about the environment. That's the risky stuff, not so much worrying about aliens or risks from other cultures. And I think that if we develop technologies that allow us to survive our future here on Earth, we would also allow the same technologies to carry us into space. And once we spread, we do not put all of our eggs in one basket, which is the Earth right now. If we spread our eggs on other planets and on technological equipment that flies through space, then we won't be as vulnerable. That's a much more elegant solution to the concerns of our vulnerability. And I would argue that we are much more vulnerable for destruction from our own civilization than from others. And that's where the attention should be, politically speaking. And once we go through the technological revolution of having robots replace human labor and having computers and artificial intelligence replace jobs that we assigned, for example, to doctors and humans in general. Once we go through that peacefully, we will have the technology to go into space and spread ourselves. And that would be the best method for survival, being in many places at the same time and not risking ourselves by being on one planet at all times and hiding ourselves on that planet.
We also have distance on our side, too. The distances are extremely vast, so it may simply not be, interstellar conflict may not be worth it for anybody because of the extreme distances involved. But do you think, just to go back to a more neutral position, do you think that we're going to find evidence of exocivilizations within the next 20 years, say? Or do you think it could be further out or very soon?
I certainly hope so. I don't think that we are special. My fundamental premise is based on modesty. And I believe that we have nothing special to offer, that what we see here on Earth exists in many other places. And that implies also that we don't need to worry so much because, if you see a lot of ants on the pavement, each of them is not really special. If you see a lot of life as we know it on other planets, we are not really special. So another civilization going through interstellar space would not really regard us as valuable or particularly interesting. And it's a sign of arrogance on our side to think that the world centers on us. It's sort of similar to the notion that the sun revolves around the earth, that the earth is at the center of the universe. We should give up on that. We are not at the center of the physical universe, that we know by now, even though Galileo was put on house arrest not so long ago for arguing for that. And by the same token, we should not argue that we are at the center of the biological universe, that we are of any special significance. Because whenever we argued for that, we found that we were wrong. And, it's a natural tendency to argue that. I saw that when my daughters were young, when they were infants, they tended to think that the world centers on them. And that was due to the lack of experience. As they matured and aged, they realized that there are many more people out there and are not very different from them, and therefore they are not at the center of the world. And our civilization has to mature, and one way to mature is to figure out that we are not alone and that we are not special. And we haven't reached that phase, but that's one of the important goals of the search for life elsewhere, that it will bring modesty with it. I really hope that people in the distant future will be much more humble. We would realize that there are more advanced cultures out there that were capable of generating technologies that far exceed our technologies. We can learn from them. and that we are not special by any means, and that the world has much more to offer, the universe at large, much more to offer than what you find by staring down on Earth and focusing on political events on the surface of such a tiny planet, one out of 10 to the power 20 planets similar to it in the observable volume of the universe.
So even if intelligent life is scarce and that some great filter lies in between simple life and more complex life or intelligent life, there's still the possibility, the sheer numbers of galaxies present in the universe, the observable universe, is mind-boggling. So the numbers are still in favor that there has to be someone.
Yes.
And this brings up, things like, if we don't see it in the Milky Way, maybe we don't exist at the same time as another exocivilization in this galaxy. We can look at other galaxies, extragalactic study.
In fact, there is another approach which is more promising. Even if they don't exist at the same time as we do, these civilizations existed in the past, and we can do archaeology of space. I call it space archaeology, where we dig into space in search for relics from dead civilizations that are not in existence anymore. And there are various forms by which you can find relics of dead civilizations. For example, you can find megastructures, structures that were created on the surfaces of other planets or in between planets by other civilizations that are not operational anymore. You can find technological equipment left over from a technological civilization that is not in existence anymore. These are dysfunctional, defunct junk, space debris that is out there that we can find. We could also find on the surface of a planet photovoltaic cells, equipment that is not in use anymore. And this will be a way of improving our chances for finding evidence for other civilizations. They don't need to be contemporary with ours. They just need to shape their environment in a way that looks unnatural, and then we would find it.
Even their trash. We produce, as we've explored space, we've produced all kinds of trash.
Right, and in fact, Voyager 1 and Voyager 2 are based on a half-century-old technology that is exiting now the interface between the solar wind and the interstellar medium. And so we are already polluting the interstellar space with these spacecrafts. And, we just started, and in the future we'll do much more.
So, and that opens up things like the Jupiter collecting interstellar objects, because you could find nothing special, just trash,
right.
Concrete, a piece of concrete, an alien civilization made, God knows how long ago, that escaped their system somehow. But
or a light sail that looks like yeah.
Now, extragalactically though, looking for civilizations in other nearby galaxies, you wrote a paper once about fast radio bursts, which are not well understood, as possibly being leakage from extragalactic light sails. What would that look like, that level of light sail?
Yes. So, in fact, before I got engaged in Starshot, we wrote a paper with a postdoc of mine, James Gwilishon, discussing the possibility that we could detect the light beams that are used for light sail propulsion. And we thought about the systems within the Milky Way galaxy, because you can imagine transferring cargo between the Earth and Mars, for example, using light sails. It turns out that the best wavelength of light for that purpose would be in the radio. And so we just imagined another planetary system where you have an Earth-Mars analog. And whenever these two planets line up along our line of sight, we might see a beam of light heading in our direction, because that would be leakage of radiation from the periphery of the sail as it pushes on it. And since the planets move in the sky relative to each other and relative to us, what we would see is a flash of light. We would see a burst of radio waves that lasts for a short amount of time, and we calculated what it would look like. Now, this would be from the Milky Way galaxy, in which you can contemplate a project like Starshot. It wouldn't be very exotic, and it would still be detectable across the Milky Way. However, if you want to detect a beam of light across the entire universe, you need it to be much more powerful. So the question is, what are fast radio bursts? Now, we know of one of them, which originates in a distant galaxy, and it's the only one for which the distance is known. It's a repeating burst that repeats many times. We've seen hundreds of repetitions. We don't know where it comes from, what the source produces it. Most astronomers adopt the idea that it must be associated with a young neutron star that was just born. A neutron star is a star that weighs roughly the mass of the sun and has a size of a big city, about 12 kilometers or so. And if it's spinning very rapidly, it can produce radio emission. We see that in the form of pulsars that have a beam of light in the radio coming back to us like a lighthouse. And on a periodic fashion. And these fast radio bursts are not repeating periodically, but there is one that repeats in a non-periodic fashion. And people say, well, maybe it's a very young neutron star that was just born and emits radio waves sporadically in a non-periodic fashion. And that's what we see as the fast radio burst coming from this source. But this is the only one for which we know the distance. And if all of them originate from cosmological distance, from the edge of the universe, you need much more power in the beam. We calculated in that paper with Manasvi Lingam that you need roughly the amount of power that is intercepted by the Earth from the sun. So basically, you need all the power that is impinging on the surface of the Earth. You need to convert that into a radio beam that is extremely powerful and push on a sail. And in this case, you can propel a huge spacecraft that weighs millions of tons. You can propel it near the speed of light. So it would be a major engineering project to construct such a system, but it's sort of the ultimate system that a civilization on a planet may develop, harvesting all the light from the parent star, using it for the radio beam, and pushing on a very heavy load, launching it close to the speed of light.
Now, this would be a civilization that obviously does not care if others see it, because it would be visible over extragalactic sails or distances.
That's right.
There's also the possibility of other technosignatures that might be just as loud. For example, there's a peculiar star called Jabilsky's star that seems to have transuranic elements in it. But this, again, could be something related to a neutron star merger and the creation of very heavy elements. It was advanced years ago by Sagan and Shklovsky that this technosignature, finding something like plutonium in a star, like what apparently has been detected with this peculiar star, is a possible technosignature. But do you think that's the case now, given what we know about neutron star mergers and the creation of heavy elements?
Well, in fact, about a year and a half ago, in summer 2017, the very first neutron star merger was detected through gravitational waves with the LIGO observatory. And we detected light from that merger of two neutron stars. And the light was produced by a little bit of neutron star material that was ejected into space that decayed radioactively and produced the light. And what we could learn from the light that we detected that accompanied the gravitational wave emission is that very heavy elements, like, for example, gold that I have in my wedding band, were produced primarily through neutron star mergers. Out of this debris of neutron star material that was ejected into space, only 1% or so, or a few percent of the mass of the two neutron stars is ejected, but that's enough to produce all the rare elements that we see, including gold. So if you ever look at a gold piece of jewelry, just think about it, that this gold was produced in the collision of two giant neutron stars, roughly the size of a city with a mass comparable to that of the sun. And that's the process by which this gold was produced. It's not produced by burning hydrogen in the cores of stars. It's produced when two neutron stars come together. Together with gold, there are rare elements, like the ones detected in this Przybylski's star. And what you can infer from the fact that they are likely to be produced in neutron star mergers is that really, depending on where a star is born, affects the abundance of rare elements in it. So if, for example, the sun would have been born closer to the site of a neutron star merger, we would have much more gold, much more uranium on Earth. And of course, both of these elements are the root of all evil. Gold is the root of wealth here on Earth because it's rare, and uranium is used for nuclear weapons. If our civilization would have existed in the vicinity of a neutron star merger, we would have had much more uranium, much more gold. So first of all, the gold price would have dropped because it would be very common. This element would not be as rare as it is. And we would be much more militarized, perhaps, with nuclear weapons. And so if we ever meet another civilization, we should first check where they came from. If they came from a site that was enriched in uranium, we should be very careful because they might have a lot of nuclear weapons at their disposal. But altogether, this illustrates the fact that stars that were born in different environments may have a very different abundance of rare elements. And you don't need to invoke an intelligent civilization to explain Przybysky's star. Potentially, it came from an environment that was much richer in these rare elements.
Back to technosignatures for a moment. This again assumes that it's a civilization that is indifferent to whether others detect them or not. But there could also be far more discrete civilizations that don't want to be detected. Now, to bring this back to Oumuamua, in your paper, you detailed that certain things about Oumuamua might be ideal if you wanted to hide the origins of the object or obscure the origins somehow. Could you explain that?
Yes. So, for example, you would make the object appear as if it originated in the local standard of rest, because there is almost no star in that frame of reference. The stars are moving relative to each other, and a very tiny minority, less than 1 in 500, is so slow in the local frame of reference of the standard of rest. And so if we see an object originating in that frame, we will not know from which star it came, or where did it come from, or what its galactic origin is. And so that is one way to hide the origin of an object, to put it in the local standard of rest. It's sort of like putting a buoy on the surface of an ocean. You can't tell where it came from. It was left there. And until we find the second object, we would not know if that's a coincidence or if it was planted in that frame of reference. One thing we know is that Oumuamua is not in that frame anymore. It was kicked by the sun. But it's possible that it would be brought back to that frame of reference once it goes far enough from us so that we can't really monitor it.
So in other words, it could, once we can't see it anymore, it could do anything and put itself back to where it originally was. Imagining alien civilizations is something we can only do based on what we, as a civilization, does. But to do that, we have to envision our own future, which doing so is notoriously imprecise. If we stepped back 400 years and asked someone to envision the future, it's highly unlikely that they would paint an accurate picture of our world of cell phones, high-rise buildings, and computers. For us to imagine a civilization conceivably millions of years older than our own, it requires us to try to imagine our own future. But would we be any more correct at imagining what our civilization will look like 400 years from now than the person we had spoken to from 400 years in the past? We can only do that speculatively at best, and then only vaguely. But as we progress, we'll get closer in our abilities to imagine what any other civilizations that might be out there could look like.
It's not over yet. Join me as we continue to travel through the cosmos on a gentle wave into another episode of Event Horizon with your host, John Michael Godier.
In science fiction, there has always been the tendency to envision the first detection of an alien civilization as something very clear and clean-cut. But in reality, that's probably not how it will actually go, and will be far more ambiguous than perhaps we would like. This has already been the case in some sense. Every potential detection we've seen has been ambiguous, from the WOW signal to the new BLC-1 signal. They look technological and may fit the bill for a true alien radio signal, but unless they repeat and can be verified, they remain ambiguous and unproven forever. This is also the case for the first interstellar object Oumuamua, which my guest hypothesizes may have been technology of alien origin passing through the solar system. But this is not settled, with most of the scientific community skeptical, and the debate goes on. And it could be that we may never know, and Oumuamua remains an open mystery forever. But the discussion does need to be had, and not just for scientific reasons and answering the "are we alone" question. It's also a matter of this planet's security. That we even saw Oumuamua is because it passed not that distantly from Earth, and its existence suggests that there is a large population of strangely behaving objects passing through the solar system at any given time, literally in our own backyard. Because of that, all potential explanations should be seriously considered.
You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Professor Avi Loeb. Avi Loeb is the Frank B. Bird Junior Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative, serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation, as well as Chair of the Board on Physics and Astronomy of the National Academies. He is the author of 4 books and over 700 scientific papers. He is an elected Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space.
Avi Loeb, welcome back to the program.
Thanks for having me.
Avi, you have written a book that is sure to make waves, that covers not only the topic of Oumuamua and the very real possibility that it may have been a piece of artificial technology, alien technology, but also indictments of why we can't openly talk about things like alien trash in the solar system and the biases that are present in that. Now, where does this start, this bias within academia that it's never aliens and it's never going to be aliens?
Yeah, I find it rather unfortunate for a variety of reasons. First of all, I don't think it's more speculative than many of the things that are being done right now in theoretical physics. In particular, take for example, the study of dark matter. We don't know what most of the matter in the universe is, and there are several suggestions, and hundreds of millions of dollars were invested already in trying to build experiments that will search for those particles. We haven't found it yet, and nobody complains. It's part of the mainstream. In the case of dark matter, we don't know what we are looking for. It could be very different types of entities. It could be black holes that we can't see from the early universe. It could be elementary particles, or it could be that gravity is modified in a way that we haven't yet imagined. And all of these are viable. Now, in the case of the search for intelligent life elsewhere, because we apparently cannot find it here, if you open the morning newspaper, you're probably disappointed. In terms of that, we know that about half of all the sun-like stars have an Earth-sized planet in the habitable zone where it can sustain liquid water on its surface and have the chemistry of life as we know it. And that we know from the Kepler satellite data. It's just a paper that appeared a month ago. And if the Earth-Sun system is so common, and you roll the dice billions of times within the Milky Way galaxy alone, what's the chance that we are special and unique? I mean, it's quite likely that if you have the same conditions, you get similar outcomes. And we should search for it, that's all. Now, this is not speculative. Imagining that under similar circumstances, you get the same outcome should be mainstream. That makes no sense whatsoever for us to be skeptical about it, to put it outside the mainstream, to just search for microbial life, primitive life. Let me give you another context for this. There was an announcement of potentially a signature of life phosphine in the cloud deck of Venus. That was announced in September 2020. And shortly afterwards, the mainstream of the astronomy community suggested that, this may not be a signature of life, even if it's there, and actually maybe it's not there. And I asked myself, the same mainstream community is trying to advocate for big missions to search for microbial life, the signatures of oxygen and methane in the atmospheres of exoplanets. And at the same time is shying away from any technosignatures. Now, if we find oxygen in the atmosphere of another planet, would that be really evidence for life? If you doubt that phosphine is, then oxygen can be produced by many natural processes. And the only way for us to actually be sure that we found evidence for life is if we find, for example, CFCs. These are the molecules produced by coolants and refrigeration systems and industries on Earth that cannot be produced naturally. The CFCs that deplete the ozone layer. And if we find evidence for CFCs, these molecules, that would clearly indicate an industrial civilization and therefore life. And so to me, for the same cost of these missions, why not talk about CFCs rather than oxygen? I mean, it's not as if we have to invest more money. It's just being more open-minded and searching at the same time that we search for oxygen in the atmospheres of planets, search for industrial pollution. So the way I see it is that there is this narrow-mindedness and conservatism in the astronomy community that prevents the search for intelligent life from entering the mainstream. And you may ask yourself, how dare the astronomy community, how dare the scientists shy away from this question when the public is extremely excited about it and science is funded by the public? So if astronomers have the tools to answer this question, they have telescopes, they have funding for future experiments and telescopes, how dare they say, let's not do it, or let's look the other way when there is some evidence?
Now, it's interesting that you mentioned the Venus detection of phosphine gas in regards to CFCs and looking for CFCs as a technosignature. Now, not only could it be industrial pollution, but it's also a very, very, very good greenhouse gas, those gases, that group. And you could terraform a planet with them. So if you saw a very, very clear, obvious marker of CFCs in a planet that might not be inside the optimal habitable zone of the star that it's around, you've just found terraformers, and you have just found aliens doing something that we can only just dream of. And that's the beauty of a technosignature, is that if you find one, it isn't just answering the "are we alone" question, it's what are they doing? What is this?
Exactly. Exactly. I should emphasize that aside from the question of are we alone, to which I'm quite confident we will find an answer, no, we are not alone, because we're not special. We have to be a little bit more modest, more humble. My daughters, when they were young, they thought the world centers on them. And then as they went out to the street, they found other kids and they got a better perspective. And so we as a civilization behaving like that and arguing, oh yeah, maybe we're alone, is immature, and obviously the way to mature is to find evidence. And I should say that once we find evidence, which I'm quite confident and could happen in our lifetime, then the question is, are we the smartest kid on the block? And if you read the morning newspaper, you realize we are probably not, because we keep investing a lot of effort in either killing each other, fighting with each other. We are not cooperating. And that's a sign of intelligence, that you work together and help each other. And instead, we are wasting a lot of resources, in fights among nations and so forth. And people die as a result and so forth. That's not a sign of intelligence. And so I believe, that we are probably not the smartest kid on the block based on the way we behave. We are not the sharpest cookies in the jar, and as they say, and we can learn from those other cookies in the jar. And perhaps we will learn an important lesson by looking at the sky. That's a learning experience. And I hope that by, seeing, for example, how other civilizations were extinguished, perished on their host planet as a result of going into nuclear wars or destroying the climate or doing something inappropriate. By seeing evidence for that, we will learn a lesson to get our act together and behave better. I call that space archaeology. Just like we dig into the ground, we can dig into space and find evidence for dead civilizations, and that would teach us important lessons.
And we may have just sort of scratched that surface with Oumuamua. Now, your new book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, when does it come out?
It comes out on January 26, 2021, and it will be published in more than 20 countries worldwide.
As I mentioned earlier, the book covers several bases, and one of these bases, of course, is the bias against, what would you say, free thinking, ultra thought, something like that within academia, especially in regards to alien civilizations.
Yeah, I would think that academia would learn from lessons of the past, and for example, Galileo, he said, no, it doesn't look like, I don't think that everything moves around the Earth. I mean, it's again this human-centric view that everything centers on us, that we are important, we are unique, we are at the center of things. And Galileo, it all started with the Copernican revolution. And Galileo said, I just look through my telescope and you will see that, it makes more sense that we are not at the center of the solar system, And the philosophers at the time said, no, we know the truth. We know the answer without looking through your telescope. He was put in house arrest, but the Earth continued to move around the sun. It didn't change anything. So my point is, we can be stubborn. We can shy away from anomalies. We can put people in house arrest. Will that change anything? What do we accomplish by that? That we remain ignorant. And what I'm surprised by is that the scientific community has this taboo on discussing these issues and shies away from anomalies. And, we have very good evidence that most of the discoveries in science came from anomalies, things that we haven't expected. It's a learning experience. We see things that we haven't thought about before. So why not be open-minded? Why bully anything that looks different? Why stick to all it just makes no sense to me.
What do you think causes this? Where does the disconnect? Because most scientists as children, they don't start out this way.
Right.
Where does the disconnect happen?
I think, unfortunately, I wrote, for example, an article in the Harvard Gazette encouraging, I was asked, what is the thing that you would like to change about the world? And I said, I would like my colleagues to behave more like kids. That's the thing I would like to change. Because kids are honest, straightforward, they experiment, they have ideas and then they check them and very often they fail, but they learn from this experience. There is nothing to be ashamed of. It's part of the learning experience. Einstein was wrong 3 times in the 1930s. He wrote 3 papers that are completely wrong. He thought the nature of quantum mechanics cannot be action at a distance. It makes no sense. He thought that black holes don't exist. He thought that gravitational waves don't exist. And then in 2015, we found gravitational waves as evidence for black holes. We have experiments that confirm quantum mechanics in a way that Einstein did not anticipate. But it's part of a learning experience. Even Einstein, the person that is regarded as the smartest of the past century, even he made mistakes. And it's nothing to be ashamed about, because we are learning new things about reality by having a dialogue with nature. The only way not to learn is to close yourself off. And you ask me, why are people doing that? The answer is simple. They are more interested in promoting their self-esteem, in promoting their image, in gaining awards, gaining status. And if you take risks, if you allow yourself to be wrong, then you might stumble here and there, and you are not optimizing your chances of getting an award or getting into a honorable society or being highly praised by your colleagues. And I claim that all of these rewards are nothing like the reward of understanding nature better. Who cares about whether another person thinks highly of me? I mean, that is irrelevant. Who cares about whether the philosopher at the time thought highly of Galileo? People remember Galileo, not these philosophers. Why? Because he said the right things. And so in retrospect, what matters is what reality, what nature is, rather than what people think it is. The number of likes on Twitter do not matter. So unfortunately, what happens in academia is people are driven by trying to promote their image, and therefore they are shying away from making mistakes. They also try to create echo chambers where whatever they advocated for early on in their career is being repeated by their students and postdocs, so that they get a bigger echo and have a higher chance of getting awards. As a result, those young people are very afraid of saying anything to the contrary, because then their prospects for getting jobs will not be great. Now, there is another layer that comes into the search for intelligent life, and that is the public is extremely interested. There is a whole literature on science fiction, and it feels as if you are degrading yourself if you are in the ivory tower of academia, if you were to talk about things that are otherwise the subject of discussion of people that do not have the expertise of being a physicist, a scientist, and so forth. And so, and it opens a lot of possibilities. And so, as a result, a lot of my colleagues prefer to maintain the image of being part of an elite. And, that is a self-inflicted wound, because then the public views academia as an elite. And I don't think that's appropriate, because I think the scientific inquiry, is just, science is a way of life. It's not really a job. If I have a leak in the faucet, or as I see something bad going in the pipe, then when I try to fix it, I operate just like a scientist. I try to figure out what the evidence is, what can I draw from that, and how can I fix the problem, And it's a way of life. Science is thinking about reality in a way that is based on evidence, trying to figure out how to act. And if you accept it as a way of life, then it's not an occupation of the elite. It's trying to figure out reality, and scientists should not be those that are elevated to a high social status. They should be every person, that has the evidence could conclude the same thing. And so I find this really unfortunate that there is this disconnect between the interest of the public in exploring this particular subject, for example, and the reaction of the scientific community, not only not to address this subject, but to bully and, say, ridicule anyone, that tries to address this subject. Because what happens then, the young people do not enter this research field. As a result, you don't have high quality scientists working on it. And then all these people that bully whoever works on this say, look, there is not much interesting stuff going on there. On the other hand, there is a lot of interesting stuff going on dark matter, on string theory. Now, we have no clue whether string theory is correct. It could be a complete pipe dream. For 50 years, they haven't made a prediction that was tested. We have no clue about supersymmetry. I mean, in fact, the test of supersymmetry indicated that at least the early versions of it are ruled out by the Large Hadron Collider. There is no evidence for the types of dark matter that were advocated for decades, for which people got awards. There is no evidence for all these speculative extra dimensions, all these speculative things. And yet they are part of the mainstream just because they are not accessible to the public. Extra dimensions involve sophisticated math. So, all these mathematical gymnastics still keeps the academia elevated relative to the public. Who cares about mathematical gymnastics? The question is, do extra dimensions exist? Let's check it experimentally. If there is no evidence for it, then this is much more speculative than the existence of intelligent life, for which we have evidence. We find it here on Earth, right? So if the conditions are replicated, why don't we search elsewhere where the conditions are replicated? So I find this situation right now as completely unhealthy and inappropriate, and I'm trying to correct it.
Now, it's one thing that you mentioned that is interesting. Einstein was wrong, but when Einstein was right, general relativity, there were still people that said he was wrong. As a matter of fact, there was an entire book with a bunch of signatures on it, all saying you're wrong, even though it was an obviously testable theory.
Actually, Einstein was asked about this book that was written about the theory of relativity, and the book had all these people contributing to it or signing on it, saying that his theory must be wrong. And he said, why do you need 30-some people to make the case? If they had a good argument, then, a single individual could have made the argument, and that's it. A kid could make the argument. You don't need authority of 30 people to make the case that the theory is wrong. Just, a good argument advocated by a kid could be sufficient. And so the mistake that people make is authority matters, and that was the case also in Galileo's days. Authority matters. Authority does not matter, and that's what Galileo said. It's even a single individual that has the correct, evidence and the correct argument could be telling the truth rather than the authority. I mean, we're not talking politics here. It's science. We're trying to figure out what reality is about. And the question is, who is telling the truth? And the only way to find out is by collecting evidence. And if you don't allow yourself to collect evidence, if you don't allow yourself to find wonderful things, you will never discover them.
This happens a lot because you also mention in the book about exoplanets and how the study of exoplanets was set back 40 years because of an incorrect consensus. Could you tell us about that?
Yeah, so Otto Struve, who was an astronomer, highly respectable, he wrote in 1952 a paper saying, perhaps we should search for a massive planet like Jupiter very close in to a star, because if it's close enough, then the star will move back and forth in a way that we can measure. And that would indicate that the planet exists around the star. At the time, people didn't know whether planets exist around stars. And so for 40 years, time allocation committees on major telescopes refused to give time, observing time, to search for such planets. Because the argument was, we know that Jupiter in the solar system is highly removed from the sun and gives it a very little tug back and forth, and it would be very difficult to detect that. And we understand why Jupiter is so far away. It has to do with water ice forming at some distance from the sun, and then Jupiter ended up with a core made of a rock, but then dressed up with hydrogen and helium, so we know where it formed. And all planetary systems should behave the same way because there is some underlying physics that we understand. And then about 40 years later, by chance, some astronomers were able to search for a hot Jupiter, a Jupiter that is close into a planet, to a star, and found evidence for it. And the Nobel Prize was awarded last year for that discovery of Michel Mayor and Didier Queloz. And the lesson of this is, you may argue, okay, science makes its discoveries anyway. In this case, it did make it. My point is, it's an inefficient process, and it was delayed by 40 years. And 40 years is a significant amount of time. Now, in this case, it happened. But imagine all these other cases where it didn't happen. I'm sure there are many cases where the mainstream community was arguing against even checking something, and it was never done as a result. And we missed an opportunity for a discovery. So for every case, when I find an ant in the kitchen, I get alarmed because one ant indicates that there must be many more that I haven't seen. And so when I see a case like that of hot Jupiters barely being discovered 40 years later, I know for sure that there are numerous cases where ideas were suppressed and as a result were missed opportunities. And, it's just a pity It's just a pity that we are not, the scientific process is not as efficient because of prejudice. It's not as if the telescope time was not available. People used it to search for binary stars, for example, but not for a planet close to a star. Why? Why would we do something that is rather boring than allocate, let's say, even 10% of the telescope time for something that is risky? So my point is simple. Let's allocate a fraction of the resources for risky propositions, because we never know what we might find. And the same is true about anomalies. If we see anomalies, we should not brush them under the carpet, under the rug of conservatism. We should not say, oh, no, we haven't seen anything. Forget about it. Nothing was business as usual. We should not do that. We should be honest rather than raise dust and claim that we don't see anything, which is very often the case. So the mainstream advocates often raise some dust and say, we don't know this, we don't know that, there is a lot of uncertainty, we don't see anything. Instead of raising dust and saying we don't see anything, just let the dust settle and admit when an anomaly is a real anomaly, and let's explore it. What's the big problem? Maybe there is something that we haven't expected.
You use a wonderful quote from Heraclitus of Ephesus in the book. If you do not expect the unexpected, you will not find it. Now, my question for you is, Oumuamua set aside, do you think it's possible that in the last 100 years of SETI and every other radio astronomy, everything, that we might have actually detected alien civilizations and missed them because of bias?
Quite possibly. I can give you an example. Gravitational lensing. That's the effect associated with the deflection of light by the force of gravity. In the Astrophysical Journal, which is the most prestigious journal in the United States that publishes papers in astrophysics, in the Astrophysical Journal, you can find papers dating back decades that showed images of clusters of galaxies where you can see those arcs that you expect from gravitational lensing of a background galaxy. So there is a source of light behind the cluster, and the cluster lenses the light by the force of gravity. And as a result, you get those arcs, which are distortions of the images, stretching of the images of the background galaxies that are being lensed. So if you look at the Astrophysical Journal, you find those images with the arcs in them. And nobody said anything about those arcs. People just, said, oh, maybe it's an artifact. I don't know what it is. This is not part of the paper. Let's move on. Business as usual. And then at the beginning of the 1980s, the subject of gravitational lensing got more popular. It was originally discussed by people like Einstein and Zwicky, many decades earlier, but it was not part of the mainstream, so people just dismissed it. And then at some point in the early 1980s, it became popular. And then people went back and said, oh yeah, you can actually get those arcs from gravitational lensing. Nowadays, people use those arcs to measure the mass inside of clusters of galaxies. And it's a well agreed upon procedure. It's part of the mainstream today. So you ask yourself, the evidence was there all along. Why didn't people interpret it correctly? And the answer is, it was not popular. If someone would have suggested, and actually people suggested that. Zwicky talked about gravitational lensing in clusters of, but people just ignored it, ignored him. He was not liked by many people. He talked about the dark matter. He was talking in a way that didn't appeal to people. Nowadays, he would get very few tweets. He would get actually bullying on Twitter because he was not popular, Zwicky. But he advocated dark matter. He advocated gravitational lensing. So what? He was not popular. Nobody paid attention to him. And then decades later, this subject became, both subjects, dark matter and gravitational lensing, became the highlights of astronomical research. So people say, oh yeah, Zwicky talked about it. But at the time, they dismissed him completely. And he was not considered, he was considered a wild card, so to speak. And what I'm trying to say is that the evidence could be there, and we are ignoring it because people simply say business as usual. People declare it publicly. Businesses forget about it. Just let's move on. It's easy to do that because if you try to deviate from that line, from the I would say the Pravda line, the official line of the party, if you are trying to say something different, you are risking future job opportunities, because those people that write Pravda, the newspaper that advocates the party's line, those people are the ones in selection committees. But then you think about it, we're talking about science, not about politics, right? So, and science makes progress by looking at evidence, and science is supposed to be based on independent thinking, but it's not. And that's unfortunate. And, I'm speaking to you as chair of the board on physics and astronomy of the National Academies, as a the longest serving chair of the astronomy department at Harvard, as a member of the President's Council of Advisors on Science and Technology, as the chair of the Breakthrough Starshot Initiative. I have a lot of formal, as the director of the Black Hole Initiative and the director of the Institute for Theory and Computation. I have a lot of leadership roles, and I'm supposed to be part of the mainstream. I'm supposed to line up with whatever everyone says, but I refuse to do that because I still am genuinely interested in what nature is about. And I haven't changed much since I was a kid. I'm really curious about these things, and I care less about what other people say.
Now we have to take a break, but when we come back, we will get into Oumuamua, which may very possibly have been a piece, or is a piece, of alien technology, which you detail very succinctly in your book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth by Dr. Avi Loeb. We'll be back in a moment. And we're back with Dr. Avi Loeb. Now, Doctor, this book's main subject has been something that's been floating around and discussed within astrobiology for a long time, but since it was discovered anyway. But if you look outside of your book, it's an open question. Nobody seems to want to even address Oumuamua now. They seem happy to just let it sit there as having been something that we don't know, an anomaly, and it's gone. And we'll never know anything more about it. But I think that is unfair because a lot of data was taken on it, and that data points in a very strange direction. This was not a normal object. In fact, it was impossibly abnormal, you could say, I suppose. What is it about Oumuamua that sets it apart from anything else?
Right. Well, it's the experience is very similar to going on a beach and looking at seashells that were swept ashore, and usually they are beautiful. Each of them is different, and they were naturally produced. But every now and then, when you walk on a beach, you find the plastic bottle that was produced artificially. And when we have looked at the sky in the past, we saw mostly rocks, icy rocks in the case of comets. And when there is ice coating the surface, then it can sublimate and evaporate when the object gets close to the sun, and you see a cometary tail as a result. So we have seen comets, and we have seen just pure rocks, asteroids, and from the solar system that were part of the debris made during the formation process of the planets and the sun. And then Oumuamua was the very first object that we discovered in the vicinity of the Earth that came from outside the solar system. So immediately astronomers conjectured that it must be either an asteroid or a comet, because that's what we have seen in the solar system. Sort of like a caveman, that works with rocks all his life, and suddenly sees a cell phone and thinks that it must be another rock. So it's completely natural, if your experience is with rocks, to think that Oumuamua was either a comet or an asteroid. The problem is that when we started to collect data, it looked like it has a very extreme shape, unlike all the rocks that we have seen before. It changed its brightness by a factor of 10 as it was tumbling around. And that indicates that the area that it covers on the sky changes by a factor of 10, because all we see is reflected sunlight. And the amount of sunlight tells us about the area projected on the sky. And imagine even a razor thin piece of paper. You never see it exactly edge on. So if the paper tumbles around and you see variations by a factor of 10 in the area that the paper projects, it means that indeed you have a very extreme geometry for the object. It's at least 10 times longer than it is wide, if not much more. That was the first indication that something is weird about this object. We have seen factors of 3 or so for solar system objects before. But then, in addition, this object exhibited a push away from the sun. And usually such a push can be provided by evaporation of ices on the surface of a rock. So, if it's a comet, what you would see is a cometary tail. But there was no cometary tail around this object. And the Spitzer Space Telescope looked very deeply and couldn't detect any heat coming from this object or any carbon-based molecules, either dust or carbon-based molecules, nothing of the type that we have seen in cometary tails before. So to a very high level of confidence, one can conclude that it doesn't have a tail that characterizes comets. So what pushed it then? And then it looked like this object started from a very special frame of reference. So this is the frame of reference that is associated with the galaxy, sort of the galactic parking lot. When you average over the motions of all the stars in the environment in our local environment, you get the so-called local standard of rest. And this object was at rest in that frame. Only 1 in 500 stars is so much at rest as this object, Oumuamua, was. We just bumped into it like a ship that is bumping against a buoy on the surface of an ocean. And the question is, why is it so rare? If this is the first object we encounter, why only 1 in 500 stars have this type of velocity, being at rest in the local frame of reference? It's sort of like a car parked in a public parking lot. Obviously, you cannot tell where this car came from. If it was moving from, you would see its trajectory coming from another garage. They would say, oh, that belongs to that person, perhaps. But this object was sort of in the local standard of rest, so we cannot tell which star it came from. And in fact, very few stars have those kinds of velocities. And then we didn't really expect to find an object like that, because a decade ago I wrote a paper with colleagues Ed Turner and Amaya Moore-Martin, where we showed that if you imagine other planetary systems being just like the solar system and ejecting rocks the way the solar system did, you wouldn't expect to discover this object. You need an abundance of objects that is 100 to 100 million times bigger than expected in order to get one of them detected, like Oumuamua was. So we didn't expect Pan-STARRS to find anything of that size, 100 meters or so, and yet we found it. So something is strange about its abundance, that you need much more stuff if you assume that it comes from a population of random objects that move on random trajectories. And then there was no heat detected from it, so then it means that it must be rather small, because otherwise we would detect the heat coming off it. We know the trajectory, we know what surface temperature it had when it passed close to the sun, yet we haven't seen the heat. It means that it's rather small, and it's quite shiny, at the upper end of the reflectance of objects that we find usually. And so it's a shiny, small object that is most likely actually flattened, a pancake-like geometry, because when you try to model the light curve, the 90% confidence level, Sergei Mashchenko, that wrote a paper about it in 2019, argued that it should be a flattened geometry, not a cigar shaped like was depicted in all these, in the popular media. So it's a flattened object that has an extreme geometry that is very long compared to its width, and then it's shiny and relatively small. And so what is it, and what is the extra push that it received. And so we suggested in a paper with my postdoc, Shmuel Bialy, that perhaps it's a light sail that was pushed by sunlight. And if so, then it must be artificial, and therefore must have been produced by another civilization. And so that's what we published in a scientific paper in the Astrophysical Journal. And of course, people immediately responded within the scientific community with ridicule, saying, oh no, that cannot be the case, with no evidence. And there was even a Nature review paper saying it is natural, period. Now, they didn't really provide any good arguments. Why is it natural? And why all these anomalies that I described can be explained altogether in a natural way. Each of them is a very small likelihood. And when you multiply small probabilities one after another, you get that the chance of getting all of them is really small. So how can the mainstream argue business as usual? That to me is a puzzle. And they just made that statement for political reasons, just to say, this is it. And so that people will move their attention away from this object to some other things and not even consider the anomalies. Now, I should say that despite this claim, business as usual, by a group of people that wrote a review paper in Nature, there were some people in the mainstream that said, okay, well, let's forget about this claim. Let's try to understand the properties of Oumuamua and try to explain them in a natural way. So one suggestion was, oh, maybe it's a hydrogen iceberg, something that we have never seen before, an iceberg made just of hydrogen, so that you will not get a cometary tail of the type that we usually imagine. The problem with that, and we showed it in a paper with Thim Huang, we wrote a paper showing that over the journey of such an object, from a birth site, which let's say is a molecular cloud or a planetary system, over the journey, such an iceberg would be evaporated very quickly. And we have never seen a hydrogen iceberg before. So we argued it's unlikely to be the case because it wouldn't survive the journey. Then some other mainstream people suggested, oh, maybe it's a fragment from the disruption of a bigger object that passed close to a star. The problem with that is usually these fragments are elongated. Fragments caused by tidal disruption of an object are elongated. And most likely, Oumuamua was flattened. Moreover, the chance of passing close to a star is the chance is very small. And most of the time you don't pass close to a star. So there should be many more objects. And why would the first one come from a rare event where an object passed close to a star? That's surprising. And then there was another suggestion. Maybe it's a dust bunny, just of the type that you find in a household. It's so porous that it has a density 100 times less than the density of air. And then the sunlight can push on it. And then you would get the extra push from that. The problem with a dust bunny is that it's very fragile. And again, it probably wouldn't survive the journey. So this just illustrates to you that, people that took those anomalies seriously had to go a very large distance to explain them, with things that we have never seen before. We have never seen dust bunnies in space. We've never seen hydrogen icebergs in space. So trying to suggest those things indicates how difficult it is to explain the phenomena that we have seen. Yet the rest of the mainstream says, oh, business as usual, forget about it, it's a natural. Making such statements serve no good purpose. You have to address each anomaly and say how do you get to explain it? Is this a likely process? Does it produce enough objects at the abundance that is needed? And, the people that attempted to do that went into things that we have never seen before. Okay, that's legitimate. So why not consider also an artificial origin as one of those explanations? And then how can we make progress? Very simply, let's monitor the sky and find another object. So with Oumuamua, we realized that it's unusual only after it was receding away from us. And then it was too late because we couldn't really chase it. It was moving too fast for any rocket that we developed. But if instead of detecting it on the 19th of October 2017,
we would have detected it in July 2017. And by the way, incidentally, that's the time when I visited Mount Haleakala in Hawaii, in Maui, where the Pan-STARRS observatory that discovered Oumuamua is. So if Oumuamua was discovered at the time that I was visiting that place, then we would see it coming towards us at that time, and we could have designed a mission to meet it halfway and take a photograph of it. But we discovered it only when it was receding away from us, and it was too late for us to chase it. So this was an unexpected visitor that came for dinner and then left out the front door into the dark night. And only then we realized, oh, it's very special, we should get more data about it. So instead, let's wait for the next visitor, because presumably it's not the only one. If it's the first one that looks so strange, then there must be more. The next one we find, let's get a photograph of it. Let's have a mission to chase it. But if you say business as usual, you would never even check others if they're unusual enough. I should say that there was a second interstellar object discovered called Borisov. It was discovered by Gennady Borisov, a Russian amateur astronomer that by chance found it. And that one looked just like a comet, a regular comet. So people came to me and said, oh, you see, this second object looks like a comet. So doesn't it convince you that Oumuamua was natural? And I said, look, when I met my wife on the first date, I thought that she's special. And the fact that I met a lot of people afterwards didn't change my opinion about my wife. It has nothing to do with it. She's still special. I'm married to her. So the fact that you find other objects that look natural doesn't mean that Oumuamua was natural. And if you find a plastic bottle on the beach and you find a lot of seashells that look natural around it, it doesn't mean that the plastic bottle is from the same origin as those seashells.
Now, let me ask you this. You mentioned shiny. Is that consistent with something like mylar, metal, or foil?
We don't know what it's consistent with because we didn't collect enough data about the reflectance as a function of wavelength of this object. So in principle, you could infer the composition if you have good enough data. But here is the problem. If your prejudice is that it's a rock, you wouldn't be even interested in collecting such data because you would say, okay, we have a lot of objects that we have seen before that appear reddish, sort of like this one. By the way, the outer solar system beyond the Kuiper belt, so the Kuiper belt is at 100 times the Earth-Sun separation, and that's roughly where the solar wind is stopped by the interstellar medium. And beyond that, there is the Oort cloud made of icy rocks left over, presumably from the formation event of the solar system. And those Oort cloud rocks, icy rocks, they are the most loosely bound to the sun. So if you imagine the solar system losing objects, most likely they would come from the Oort cloud. When there is a passing star, it could rip some of these objects apart from the solar system. But these objects are exposed to the same environment as interstellar objects that are unbound to the solar system, like Oumuamua was. We knew that it's unbound to the sun because it was moving too fast, and so it cannot be bound to the sun, and it went, in another direction, also unbound to the sun. And so these interstellar objects are exposed to the interstellar medium of the Milky Way galaxy, but the same is true for the Oort cloud objects because they are not protected by the solar wind. The solar wind is stopped much closer to the sun, and at 100 times the Earth-Sun separation. The Oort cloud goes to 100,000 times the Earth-Sun separation. So there is a vast space of icy rocks bound to the sun that are exposed to the same environment as interstellar objects. And in principle, they should have the same surface damage as interstellar objects. So if we see an interstellar object that doesn't look like those Oort cloud objects, that would be a good indication that perhaps it's made of something different.
which seems to be the case for Oumuamua. Now, the local standard of rest that you mentioned, as you said, that erases any data on where it came from. So if an alien civilization wanted to send a probe to our solar system, but keep their origin secret, that's exactly what they would do. They would just leave it in the middle of the road for the car to run over, right?
Yes, I mean they might not even intend us to get close to the center of the solar system. You can imagine a network of such objects being placed as relay stations for communication. You know, that there is no need to communicate by sending a signal across the galaxy, because then you need much more power. You can just have relay stations, either for communication or for navigation, sort of like signposts spaced throughout the interstellar medium. You can have those, and the natural system or frame of reference to put them in is the local standard of rest, where they are not associated with any individual star. They're sort of sitting there as signposts. Or there could be such objects that are intended to dive in to the habitable region of planetary systems, and maybe that's another possible interpretation. I don't know what the interpretation is, but the only way to find out is by collecting data on other anomalous objects. And so my point is really simple. I don't necessarily say that I know for sure that Oumuamua was artificially made, but I say it looks strange for the first object that we have found. It looks like a plastic bottle. Let's keep our eyes open for another one that may look strange, and then take a photograph of it, investigate it, get as much evidence as possible. Why have prejudice before we examine what reality is like?
It also seems strange that Oumuamua, not only for being such an unusual object and the first interstellar object we unequivocally saw, but also that it passed relatively close to Earth, almost as though let's tell ourselves a story that it was an alien probe. It did what an alien probe would do. It would see this interesting planet and pass relatively close by to it, right?
Right. Now, you might argue, okay, otherwise we wouldn't notice it, because we rely on reflected sunlight that reflects off the surface of this object. And if it passes too far away, we wouldn't see it. But we will never know, of course, what the reason is that it passed so close to us. Yeah.
As Oumuamua left, it accelerated very famously, which got a lot of media attention. But the idea of something accelerating isn't unusual in and of itself. Comets can do that, outgassing and things like that, rocket effect. But this one did it very smoothly and without very much evidence of what exactly was going on there. What is the best way to characterize Oumuamua's exit from the solar system?
Yeah, so interestingly, the amount of push that it received, if you wanted to account for it by the evaporation of water ice, let's say, on the surface of a comet, you would need to evaporate about 10% of the entire mass of the comet in order to give it the push that was detected. So it's a substantial fraction of the mass of the object that needs to get evaporated. It's not a small amount, and we haven't seen any evidence. And so that's point number one. Then the other thing is that the push was very smooth with distance from the sun, and it changed, the extra force changed roughly as inversely with the distance squared. And if it was water ice, it doesn't follow an inverse square law, because there is a certain distance from the sun where water doesn't sublimate, doesn't evaporate anymore, and so suddenly you stop having this push. So there should be sort of a step, and there was no step like that in the evolution of the orbit of Oumuamua. It was a very smooth push, inversely scaling inversely with the distance squared from the sun, and that's what you expect from sunlight pushing on a light sail. I should say there was, in September 2020, there was another object discovered. This one was bound to the sun. Actually, it followed an orbit very similar to the orbit of the Earth. And it was given the name 2020 SO by the Minor Planet Center. So it was thought that maybe it's an asteroid or something, an object that was trapped in an orbit similar to the orbit of the Earth around the sun. And then this object exhibited a trajectory that showed evidence for a push by sunlight. And it didn't have a cometary tail. So the same qualities of Oumuamua. But then the astronomers integrated the trajectory back in time and found that it intercepted the Earth in 1966. And then they went to the history books and found that in 1966, there was a mission for a lunar lander that failed, and the rocket booster of that mission was launched into space. And so very likely this is the lost rocket booster. And it's a hollow, a relatively thin piece of metal, and that's why it exhibited the extra push from the sunlight. So here is an artificial object that we identified in the sky as having no cometary tail, as exhibiting a push from sunlight, and we concluded that it's artificially made. We made it. So to me, that's a confirmation of the fact that you can identify artificial objects by the way they behave. And it's again strange to me that nobody pointed out, oh, yes, this is a rocket booster from 1966 that we produced. It behaved in a way that looks similar to Oumuamua, even though it's bound to the sun, in the sense of showing the extra push from sunlight. And we know that it should have done so because it had a large surface to mass ratio. So it was a very thin structure that we produced. So doesn't that give you some confidence in the idea that we can identify objects based on the fact that they don't have a cometary tail and they show an extra push from sunlight? We can identify them as being artificial. So perhaps that argues that Oumuamua is artificial. Nobody made this point. And once again, business as usual.
Now, I am going to get one question for sure from the public, and I'm going to get it many times, so I must ask it. If Oumuamua is artificial technology and shows clear indications that it may be, should we take the UFO phenomenon more seriously and actually try to figure out once and for all, is it real or isn't it? What do you think?
Yes. So my view on UFOs, which are objects that are flying close to the surface of Earth, that are unidentified, and there are reports about such objects by pilots. There was a recent release of reports by pilots and other soldiers. And my view on these is that they are unlikely to be associated with alien civilizations. And the reason is simple. The evidence for UFOs was always on the borderline of being credible. It was never up to the scrutiny of scientific evidence. So it's always like based on fuzzy images, on some strange behavior. And my point is that our technologies evolved significantly over the past 50 years. So something that looked fuzzy 50 years ago with the present day cameras should be crisp, clear. We should be able to tell that they are out there, yet the evidence is always marginal. To me, this indicates that there are probably artifacts of the instruments that we use, because these would always exist. We would see something that looks strange just because our instruments for detecting those things misbehave. And that's my... So let me explain my premise. My point is, I don't think we are sufficiently interesting to distant advanced civilizations. I think most likely we are just like ants on a pavement, on a sidewalk. And when you are a pedestrian walking on a sidewalk, you don't pay special attention to every ant that is under your feet. These are primitive forms of life that are not noteworthy. They don't merit special privileges or attention. And I think that we are not special. I mean, it's sort of like those people that dream that a prince on a white horse will show up one day and pick them up. Like we as a civilization dream that maybe we're so important that they would come and visit us. But I don't think we are. I think we are a very common form of life, probably not the most intelligent. There are civilizations that are maybe 1 billion years more advanced than we are technologically, and their technologies would look like magic to us. And given that we are not special, unique, or we are still relatively primitive, there are many things like us throughout the Milky Way galaxy. So why pay special attention to us? I don't think they will come and visit us anytime soon, and they haven't done so in the past. So I'm quite skeptical that we merit an answer to Fermi's paradox. I think Fermi was showing arrogance in saying, where are they? Where is everybody? If you hold a party and nobody shows up, you can say, where is everybody? And obviously, the reason nobody showed up at your party is because you're not very interesting. Why would they show up? I mean, why would they care about you? You are assuming that you are so important that they must come and visit you if they exist out there. But they can have their own parties. They can be, in fact, if they are so advanced, they would isolate themselves in a cocoon. They will build their own habitat. I call it social distancing at a cosmic scale. It's now with the pandemic, we have our own social distancing. But you can imagine a very advanced civilization closing itself off, because it doesn't want to lower its quality of life. It has its own habitat. It enjoys everything it needs. So if you have such a cocoon that closes off an advanced civilization and they don't care about communicating with anyone else, the question is, will we ever find about them? And my answer is potentially yes, because they have to throw trash out. That's the second law of thermodynamics. Trash must be produced if they are using energy. And, it's sort of like investigative journalists that go into the trash cans of celebrities in Hollywood trying to find out gossip about their private life. We could examine the trash thrown out by those advanced civilizations and learn something about what goes on in their cocoons. But it's not at all clear that they would come after us and show their existence on Earth. And I think the evidence is clearly not up to the scrutiny of scientific evidence. There is a clear difference between Oumuamua, because there, telescopes that are used by the scientific community discovered those anomalies. It was not a matter of, a pilot just seeing something unusual.
And we have to take another break. And when we come back, we will get deeply into the budding field of astronomical archaeology, studying alien objects in space that may be passing through all the time or even landing on Earth in the form of meteorites. I am joined today by Dr. Avi Loeb, author of Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. We'll be back in a moment. And we're back with Avi Loeb. Now, Dr. Breakthrough Starshot. Now we can get a laser-driven light sail to Proxima Centauri very quickly. It seems to me, couldn't we use the same technology to catch up to Oumuamua?
Yes, in principle we can, but we don't have the technology as of yet. We just started doing the research for the elements of this technology, namely how to create a powerful laser beam and how to create a light sail that is lightweight and yet sturdy, and also how to communicate with such a light sail. We only started to explore these technology frontiers over the past few years. So it will take us some time to reach the goal of building the infrastructure needed for such a scheme. But if we had it today, then of course we could have chased Oumuamua. By now it's a little too late, because as Oumuamua recedes from the sun, it gets fainter. And it gets fainter like inversely with the distance to the fourth power, because the amount of sunlight intercepted by the object scales as inversely with the distance squared. And then as it gets farther from us, we get another factor of 1 over distance squared for the flux that we receive. And so altogether, it gets dimmer and dimmer inversely with distance to the fourth power. And that's an extremely strong dependence, because it means that relative to the time when it was nearest to us, it's now at this time, it's 1 million times fainter than it was back then as a result of reflected sunlight. So if you ever send a mission to chase it, we don't know exactly where it went to the precision needed. You would need to equip this spaceship with a big enough telescope that would detect the reflected sunlight, a very faint object. That's almost impossible at this point in time. So we should maybe focus our attention on the next object that would look unusual, like Oumuamua, and meet it halfway when it's approaching us rather than chase it. And that would be a way of learning from a photograph much more about its origin.
Now, say we do see another Oumuamua, something with these weird characteristics. Can we do something so simple as fire a laser at it and try to accelerate it ourselves and characterize it that way?
Yeah, that's an excellent idea. That's one possibility, yes. It would tell us, whether indeed it responds to light like a light sail, whether indeed the origin of its push is the sunlight reflected off it, just like the wind reflects off the sail on a sailboat. So we can check whether that's indeed the origin of the extra push by shining on it rather than visiting it. I should say that in general, the light sail technology is a powerful way of exploring the Milky Way galaxy. You can imagine parking a lot of light sails around a star that is about to explode, a massive star that will go supernova, let's say in 1 million years. So you can put a lot of light sails around it, and then the explosion of the star will create so much light that it could push these light sails close to the speed of light. And they would surf on the light coming from the supernovae, just like surfers on the beaches of Hawaii, surfing on a giant wave, and in this case, a wave of light coming off from the explosion of a star, supernova. And so you can imagine a natural way of actually accelerating light sails based on a very bright source of light, like an exploding star, that could send off a lot of the light sails at a speed that we wish that we can accomplish with the Starshot initiative. And I should say that we are just at the beginning of developing our technologies. If you have a civilization that was around for 1,000 years, technologically speaking, or 1 million years, or 1 billion years, for them it would be trivial to get to this point.
This is the very beginning of astroarchaeology, or you could say another branch of astrogeology, because you get two things here. It is possible in principle that with interstellar objects passing through the solar system, that occasionally a sizable one might land on Earth as a meteorite. And it's possible that it could be an artificial one, a piece of alien technology landing on Earth. What would that look like? I mean, what would we just find a piece of titanium or something like that just wouldn't be possible in nature? What would we see?
So it really depends on the size of the object. The object needs to be larger than a person in order to survive in the atmosphere. Otherwise, it burns up as it goes through the atmosphere. It would look just like a meteor, and most meteors are not examined very closely when they pass through the atmosphere. Most meter-sized meteors are not studied in great detail, and some of these burn-ups may represent the burn-up of an artificial object. We haven't noticed it. Of course, if the object is big enough, then the core of the object can survive the passage through the atmosphere, and it would land. Most of the time, it would land at the bottom of the ocean. Every now and then, it would land on some surface of the Earth that we can examine. And then, of course, we could look for artificial objects. Most of the time, most of the objects in the solar system are not interstellar. They are associated with those asteroids or rocks that were left behind from the formation of the solar system. And most of the time, we would find natural sources like those seashells that I mentioned before. But perhaps every now and then, there might be an artificial object. And another place that is even better for us to search on is the moon, because the moon doesn't have an atmosphere. So nothing burns up. The moon is sort of like a museum that collects everything that comes its way. And there is not much geological activity. On Earth, if something hit the Earth more than 100 million years ago, then by now, geological activity would turn it around and it would be mixed with the inner layers of the Earth. But on the moon, there is no geological activity. And at best, it can be buried 10 meters deep, not much more than that, depending on the impact. And then in principle, we can look at those scars that the moon has from impacts of objects and search inside of them, inside those craters, search for perhaps a rare artificial object that was collected by the moon. Now, of course, these are not objects that can navigate or try to avoid impacts. These are objects that were sent out and then either became defunct, they're not operational anymore, or they're debris from objects that were left in space after a long time. And, it would be really interesting to examine the surface of the moon and Mars, I should say, for collections of such objects. Once again, this was not done, and we should be open-minded about it. It's sort of like a fishing net where you collect fish, and you might collect also plastic bottles in it. And of course, I should say that the solar system also has interstellar objects that were trapped by Jupiter and the Sun. They act as a fishing net. Every now and then, an interstellar object comes close enough to Jupiter so that it gets deflected and trapped inside the solar system. And we can find such objects. There are already some candidate objects. We wrote a paper about that with Amir Siraj, my student. And, in principle, you don't need to wait for an Oumuamua-like object to come through. You can go to these objects that look peculiar in the sense that their orbits are inclined relative to the orbits of the planets. And presumably they were trapped from interstellar space, and you can examine them. So one can design missions to objects that were trapped by the solar system.
And it pays to note here, too, that there is another aspect of this. Imagine the value of searching the moon or searching our own meteorite collections here on Earth, trying to identify which meteorites might be of interstellar origin, because all of a sudden you have a sample of an entirely separate planet-forming region, a solar nebula, and you can look at things like, what are the phosphorus concentrations in this meteorite? Because we know that within astrobiology, there's a problem called the phosphorus problem, and that it might be scarce in some areas, and that might preclude life. Well, we can look at these interstellar objects and say, how much phosphorus is in that, and see if that really holds true.
Yes. I should say so we went to a public data set of near-Earth objects, and including meteors, and looked at the data with my student Amir Siraj, and we did find one object whose orbit indicates that it was unbound to the sun. And so we pointed this out in a paper that we wrote a couple of years ago, saying perhaps this meteor that was identified in the catalog, perhaps it's the very first interstellar object, because it was discovered a couple of years before Oumuamua was discovered. And I was very disappointed by the response of the scientific community, because this meteor was discovered by sensors that are used for national security, for the defense of the country against the ballistic missiles, for example. And of course, this is classified information. So they put out just the data on this and other objects without giving official error bars, how uncertain are the measurements. But presumably these measurements are very accurate, and we actually received the information that they're quite accurate. But the referees of the paper said, we don't trust these numbers that came from classified information, therefore the paper should not be published. And we tried to publish it, but we were blocked by the mainstream of people that work on meteors, because they didn't want this to be announced as the first interstellar meteor. They had a problem with that. And they basically argued that they don't trust the government, they don't trust the error bars, even though if you think about it, the measurements need to be extremely accurate because, if they were as uncertain as the referees were arguing, a ballistic missile that was supposed to hit New York City would hit Boston. You can't have sensors that are so inaccurate. And therefore, I have complete trust that these measurements were quite accurate and that this was most likely an interstellar meteor, but we were not allowed to publish this paper.
Any data on how big it might have been? Was it sort of just a dust grain, or could it have been something more substantial?
This was a substantial, a few, meter-sized object that was definitely detected. The only question is whether its trajectory was measured precisely enough to be confident that it came from outside the solar system. And we checked with people behind the fence, the national security fence, and were told that the aero budget would not allow it to be bound to the sun. But the referees, the reviewers of the paper, refused to publish it. And I was disappointed by that. And I should say, I was pointing this out in a Scientific American article that I'm disappointed by this response. And then the referees complained about my disappointment. Now, the referees know me by name. I don't know who they are. And it just shows you the imbalance in power. They can reject the paper based on just the assertion that they don't trust the error bars coming from, the national laboratories. I don't know who these referees are. I just point this out in a Scientific American essay, and they complain about me pointing this out. And, once again, it shows you how unhealthy the atmosphere, how acidic the atmosphere is to innovation.
And one must, yes, you may not trust the government's error bars, but a lot of them trust the government's money as far as funding and things go. And I have to admit, I am delighted to hear that the powers that be in national security can tell the difference easily between a nuclear weapon and a meteorite entering the Earth's atmosphere. At least that's reassuring. Now, this idea of collection points at Jupiter, this offers a pristine way to look at it. They don't have to pass through the atmosphere, these interstellar objects. They don't need to burn up or acquire fusion crusts. We can just go look at them. How difficult is it to get out to those collection points that Jupiter deposits material in? And I know that there are two candidates for burned out comets that may have originally been of interstellar origin. So what do we do to go out there and take a look at those?
It has to be defined as a space mission, just the way we visit Pluto or visit other objects in the solar system. It has to be defined as a goal to go near these objects and study them. And depending on the size of the mission, again, if we had the Starshot, we could have sent a spacecraft that is equipped just with a camera in the direction of these objects. So actually, it would be nice if future space missions would be cheaper because you send a very small payload, like a CubeSat or something smaller, that doesn't cost much, but you send it more frequently rather than have a decade-long mission design phase and so forth. You can send those cheap probes whenever you need it to multiple targets. It would be nice if we operated that way. And then we can look at targets of interest like those objects, and it wouldn't be too expensive. Right now, we don't have such a framework that allows us to send missions to distant objects at a relatively low cost. So it would be nice. I should say that currently there is another aspect to this entire question that we were discussing, and that is, what do we do with our own things here on Earth? Currently all our eggs are in one basket. Everything that we hold precious to us is on Earth. And if something catastrophic happens on Earth, like, for example, a big rock hits the Earth and kills us, just like it killed the dinosaurs. The dinosaurs didn't have astronomy, they didn't have telescopes, they couldn't protect themselves. They just saw this giant rock coming in. It must have been a beautiful sight, coming in, and boom, and they die. We potentially could deflect dangerous rocks heading our way. But you can imagine other catastrophes, including the climate and so forth, within the next century or so. And then, if we perish, there will be nothing left. So it makes sense for us to spread our eggs, not to have them in one basket. And for that purpose, we can send missions to various places and put things that we care about in other locations. And, it's sort of like, I wrote a Scientific American article about it. It's sort of like Noah's Ark, the biblical story of Noah responding to the great flood, the risk from the great flood. He put animals, he built an ark. And by the way, this ark had dimensions very similar to Oumuamua, roughly 100 meters in length and 15 meters in width and so forth. So it's all spelled out. Anyway, he built an ark, and he, according to the legend, he put animals in it, and they survived the flood, and that's why life continued on Earth. So similar to Noah's Ark, you can imagine Noah's spaceship, creating a vehicle that preserves life beyond Earth, so that we don't have all our eggs in one basket. Now, you don't need to build a huge, gigantic spaceship for that, so that it can accommodate elephants, whales, birds, and so forth. You don't need to do what Noah did. Now, with modern science, you just need to know the DNA of everything that you hold precious, all these animals. You need to have an artificial intelligence computer system that stores all the DNA information. And you have to have the machinery, maybe a 3D printer, that is able to use raw materials that it finds on another planet in producing life, synthetic life. So we need to understand how to make synthetic life. We don't know it yet, but we might within the next decades understand how to do it. And then you don't need to carry these animals in a Noah spaceship. It could be just a CubeSat that has this computer and a 3D printer, and then it makes those animals, or at least the DNA associated with these animals, makes it on another planet. And that sounds much more attractive, because, for us to live in space, it will not be easy. It's a very hazardous environment. There are cosmic rays and so forth. So a much more elegant way is to send out a piece of technology that would reproduce what we care about on Earth elsewhere.
Flip that around. An alien civilization could do the same thing and send their genetic information out into the galaxy, which opens up the possibility of humanity at some point in the future finding alien genetic material that could be reconstituted into an alien, or 3D printed, as you said. Meaning that this is one way the human species, for better or worse, this could easily turn into a nightmare, but could actually see an alien.
Yeah, I should say that, although it's most likely that we came from a chemical soup on the surface of the Earth, that some chemicals came together and made life as we know it, and us as the end products of that process. It's also possible that we were planted on Earth, and that's called panspermia, from another place. And that doesn't solve the question of the origins of life. You still need to produce it somewhere else. But it helps in spreading it away, in many locations. If you manage to make it in one place, then you can plant the seeds in many other places. It's possible, that we originated in a laboratory somewhere, that our ancestry leads to a laboratory of another civilization. And, finding our roots would be to trace them back to that laboratory. Now, I should say, if you go along this path, there are papers in the scientific literature talking about the possibility of producing a universe in the laboratory, something like the Big Bang. In principle, if you irritate the vacuum enough, the vacuum, a whole universe might pop out from the vacuum. And people discussed it in papers in the literature. We don't know exactly how to do it, but in principle, it's possible. And that would solve the origin of the Big Bang. What was there before the Big Bang? Because perhaps our umbilical cord leads to a laboratory of another civilization that created our universe at some point in time. So the Big Bang came out from an experiment in another laboratory. And, the nice thing about this idea is that our universe is now producing technological civilizations like ours. And at some point in the future, technological civilizations like ours may produce baby universes. So you can have the sequence of baby universes born out of existing universes one after the other that could perhaps explain why the universe had a beginning in time according to the Big Bang theory. But even if you give up on this rather exotic idea, it's possible that life started in another laboratory, or that we would produce synthetic life. I would say within the coming decades, that's quite likely that we will be able to produce synthetic life in the laboratory.
This idea of creating universes in the laboratory, could you imprint a message? And I'm sort of hearkening to Roger Penrose here. Could you imprint a message some way onto that universe so that any inhabitants in it, say you fine-tuned it, say you looked at the anthropic principle and recreated it with your universe, could you leave a message for the people in there, should they ever arise?
I think that the most natural message is, if they are intelligent enough, they will figure out that in fact it's possible to make a universe in the laboratory, so they would make it themselves and then understand where their universe came from. So the message is that everything we see would point to the possibility that the Big Bang started from an artificial process. And currently we are lacking a theory of quantum gravity, a theory that unifies quantum mechanics and Einstein's gravity. And if we had such a theory, we could extrapolate beyond the Big Bang. We could have asked the question, is it possible for our universe to start out of nothing, out of the vacuum? We are not sophisticated enough yet to have a theory of quantum gravity that is trustworthy, that can make predictions. There are contenders for such a theory, like string theory or other quantum loop gravity and other theories. But at the moment, they haven't made the predictions that give us confidence that we are on the right track. But if at some point in the future we'll be able to have a good working theory of quantum gravity, we might be able to figure out that the message is actually in the details of our universe, that we would figure out that such a universe can be created artificially, and then we will realize that our umbilical cord leads to another laboratory.
Now let's just take it. Let's take a sort of a thought experiment, a fun look at one weird aspect of the universe, the axis of evil problem, where the cosmic microwave background radiation appears to in some way correlate with the plane of the solar system. This should not be. Those two things are not related. Yet, observationally, it seems to be there. It's a little bit colder on, one hemisphere than the other in the CMB. So should we take that seriously and ask questions like, could that be a message, or could that be, did the creator sign the painting with that, or is it just very likely not to be the case?
Yeah, again, just like the UFO reports, this puts a lot of emphasis on us being in a special status, that we are important, therefore the message was intended for us to live in the solar system. Now, the Copernican principle, that's the principle that asserts that humans are not privileged observers in the universe, that we are not special. That's my starting point. Out of modesty, I call it cosmic modesty, we should not pretend that we are privileged observers. We are at a typical place, at a typical time, under typical circumstances in the universe. That's my working hypothesis. We find life on Earth. We find many other Earth-like planets that have similar conditions. Life like ours is there, quite likely. That's my working hypothesis. We are not privileged. We are not special. We have a solar system, that doesn't have anything to do with the microwave background that came from very early cosmic times. It just so happened that the solar system is oriented in a way that lines up with a cold spot. Who cares? So I would just say it's in my book, it's better to be modest and humble and not to pretend that we play a special role and things are really aimed to send us specifically a message, because we are not special. We are not unique. And our solar system is one out of so many others that are oriented in random directions. So why would the message be just for our solar system? So I suggest let's just be more humble and modest and assume that we're nothing special, and then explore the universe from that starting point. That seemed to work for cosmology, the study of the universe. We found, of course, the ancient Greeks, Aristotle said, oh, the earth is at the center of the universe and everything else moves around it in spheres, And then Copernicus realized, no. And of course, we now have the idea that, the sun is one out of billions of other stars that look just like it. The Earth sun system is very common. Half of the sun-like stars have a planet like the Earth at the same distance. Nothing is special about us. And then we are all in the Milky Way galaxy, but there are billions, tens of billions of galaxies just like the Milky Way, many other places. And on very large scales, the universe is nearly uniform. So really, we are not at the center of anything. There are many things like what we see around us that exist elsewhere. We are not privileged. Okay, so we know that based on data for the physical universe. Yet, we don't know it for the biological universe or for the technological universe. I suggest let's maintain the same principle. It worked for the physical universe. I think that we are probably not special in terms of biological creatures and technological creatures. So let's assume that we are not privileged. And then from this starting point, explore. If we were to believe that we are special, we might not explore. And that's what the mainstream is doing right now. And that's unfortunate.
And we have to take another break. I'm joined today by Avi Loeb, author of Extraterrestrial, the First Sign of Intelligent Life Beyond Earth. And when we come back, we will talk about a mysterious signal that was recently picked up coming from the direction of Proxima Centauri. Back in a moment. Now, Dr. Loeb, Project Starshot, the target is the nearest star to Earth, Proxima Centauri. Now, we have recently, SETI, and a SETI experiment has recently identified an interesting signal that appears to emanate from that area. Now, it's best to caveat before we go into this story was leaked, and the data is not out there for us all to, look at. But what does that change? Does that change the timetable of Starshot? Does it suddenly become the most important thing we could do? Is send microprobes to Proxima Centauri to see what this is.
Yes, so this signal that is called the Breakthrough Listen Candidate 1, BLC1, is the first signal that could not be ruled out as human-made on Earth, and looks suspicious coming from the direction of Proxima Centauri. But it could still be human-made. For example, there could be some oscillator that is producing emission at a very narrow frequency band of only a few hertz, centered on 980 megahertz, that is drifting slightly over time, that is artificially made by humans, and we just haven't identified it, and it's coming into the side lobes of the telescope. That could be the case. Perhaps it's the most likely interpretation. So we still have some work ahead to figure it out. And of course, one way is to use a different telescope in the southern hemisphere, a different radio telescope, and look at the direction of Proxima Centauri. Presumably, the environment will not pick up the same contamination from another location on Earth. And that would be a clean way, if the source repeats, a clean way of identifying that indeed it's coming from the sky, from Proxima Centauri. And moreover, we know that there is a habitable planet around the Proxima Centauri, an Earth-sized planet in the habitable zone where liquid water could allow the chemistry of life as we know it on the surface of the planet. It's called Proxima b, and it's 20 times closer to Proxima Centauri than the Earth is from the Sun. That's the distance at which the surface temperature of the planet is similar to that of Earth, simply because the star is a dwarf star. It's 12% of the mass of the Sun. It's much fainter, so you need to get closer to the furnace in order to maintain the same temperature. And obviously, the first thought that comes to mind is perhaps there is a civilization on Proxima b, and it transmits at this frequency that we detected. As soon as the news report came out on December 18th, 2020, I was able to immediately calculate the expected drift in the frequency of the signal as a result of the acceleration of Proxima B around its star. We know how much acceleration Proxima B has around Proxima Centauri because we infer the existence of Proxima B from the reflex motion of Proxima Centauri. So we see the star moving back and forth with a period of 11 days, and from that we infer that there is a planet pulling it back and forth with that period. And we see how much it moves back and forth, so we can infer how much the planet is accelerating back and forth. Just momentum conservation. So we know for sure how much acceleration the planet should exhibit over time. And given that acceleration, I calculated that the drift in the transmitter frequency would be much more than reported. I was not part of the discovery team. I was not aware of this discovery, but just thanks to the excellent reporting, both in The Guardian and later in Scientific American, I was able to infer that it cannot be a transmitter on the surface of Proxima B. And now the question is, it could still be a transmitter somewhere in that direction that has nothing to do with Proxima B. And one may wonder whether it's at all plausible for a radio signal to originate from the nearest star to us. So once again, I advocate the Copernican principle, which says that we are not privileged. We are not privileged observers. There is nothing special about the present time. Now, we know that on Earth, radio technology started about a century ago, and Earth existed 4.5 billion years before that. So we know that the window of time over which we were transmitting radio waves is a tiny fraction of the age of the Earth. And if we say, okay, we are not living at a special time, then the chance of another star emitting in radio waves near us is extremely small. And we quantify this argument in a paper with my student Amir Siraj, basically making the point that the Copernican principle implies that there is an extremely small probability that the nearest star to the sun is emitting in the radio right now so that we can pick up the signal. And I should say there is one caveat to this conclusion. The caveat is, unless technological advances here on Earth are correlated with those in Proxima Centauri. And you might say, why would they be correlated? Well, one interesting point about Proxima Centauri is that, stars come and go to the vicinity of the sun. And Proxima Centauri came to our vicinity at about the same time that Homo sapiens came to exist on Earth. So is it just a mere coincidence? Or was it perhaps the result of intelligent life being planted in both places at the same time? That's the only caveat that I can see, if there was a correlation between the two stars. Otherwise, I would argue it's very likely that this signal that was detected, BLC1, was made by humans here on Earth. And it's a one-time thing, just like the WOW signal that we haven't identified, but it must be something, in Australia near the Parkes telescope, some oscillator, cell phone, microwave oven, whatever, that produced this signal, then doesn't produce it anymore.
It's also worth noting that there is a sort of suspicious aspect of this signal. The frequency is very close to just a number, instead of so that seems to, and it's within the variation of what a bad oscillator might produce off from the target, transmission frequencies. So this sort of looks suspiciously like interference of some type.
Yeah, because the unit of hertz will not be common to us and another civilization. It's based on the definition of a second, and the definition, a second was defined by humans in a completely arbitrary way. You can measure time differently and define your unit of time differently than a second. So if it's an exact integer in hertz or in inverse seconds, for another civilization, it will not be an exact integer. And why would they produce radiation exactly at that frequency? That's a good point, yes.
It's interesting that you mentioned the idea of correlation. If intelligence may have been somehow kicked off on both star systems at about the same time, that's interesting. But that also requires some measure of co-development, doesn't it? Because we may have had radio 2,000 years ago if the Roman Empire had been a little bit different in its technological arc. So,
and the question is, how long will radio technology survive into the future? I mean, we are in the first, after the first century of its existence. If we live for 1,000 years, our culture exists for 1,000 years into the future, then maybe it's not so unlikely if you have a mismatch by 1,000 years. But you're right, that's a good point. I should say there are other ways to search for a technological civilization of Proxima b, and I wrote papers about it. One, Proxima b is 20 times closer to the star than we are from the sun, and as a result, it's expected to be tidally locked. It faces the star with the same side at all times as it orbits the star. So there is a permanent day side and a permanent night side. And by the way, my daughters argue that the sunset strip, which is a permanent sunset strip between the two sides, would have the highest real estate value because you can have vacations there on that planet if there is a civilization. But anyway, putting that aside, you can imagine that a technological civilization would try to put the photovoltaic cells on the permanent day side in order to produce electricity that would warm up the cold night side, permanent winter side, so to speak, and also illuminate it. And in that case, we could search for the reflectance of those photovoltaic cells. If they cover a significant fraction of the landscape of the planet, we would see some very unusual reflectance of the starlight from the surface of the planet, which we can examine with future telescopes. But in addition, we could find evidence for artificial illumination of the dark side. It will not be completely dark, and that would indicate that it perhaps is illuminated. It's easier to detect that if, for example, our hypothetical neighbors use LED lamps, light-emitting diodes that emit in a narrow band, because that is easier to detect with, for example, the James Webb Space Telescope that will be launched next year. So there are ways to infer the existence of technology on our nearest neighbor habitable planet and that are different from a radio signal.
So, in other words, if they have photovoltaic cells sitting on the surface of their planet essentially becomes shiny, just like Oumuamua.
Exactly, shiny, but also one feature of photovoltaic cells is they reflect much more at wavelengths that are longer than some threshold because they use light just like plants do. Plants have the red edge where they use up ultraviolet light, but they don't need to use red light. And so they reflect infrared light, and they're extremely bright in reflectance in the infrared. We don't have infrared eyes, but if we had, we would see plants glowing in infrared, even though they absorb a lot of the ultraviolet. And obviously, the infrared photons are considered as trash for the plants. I mean, they can't do photochemistry with them. So they just reflect them. They don't need them. They use the optical and ultraviolet photons. And photovoltaic cells have a similar feature, except the spectral edge is not the same as plants, as vegetation. And so we can look for an abrupt change in the reflectance of the surface of Proxima b, and that would be indicative of photovoltaic cells.
It's not over yet. Join me as we continue to travel through the cosmos on a gentle wave into another episode of Event Horizon with your host, John Michael Godier.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. More on that later in the video. Dr. Loeb, welcome back to the program.
Thanks for having me. It's a pleasure.
Now, Doctor, the Galileo project, it continues to grow and form up and gain members from a very diverse crowd, which includes both scientists, eminent scientists, Brian Keating, Paul Davies, many others, and then also people from the ufology community, Lou Elizondo and Chris Mellon, who's former Deputy Secretary of Defense for the United States. And so it's healthy, it seems so far. Now, what are you guys talking about? Now, are you planning the cameras and the, how to exactly look for UAP?
Well, let me first say that my philosophy is to have a wide tent that includes people with a diverse range of expertise. That includes people that have gained knowledge while studying the subject for many years or decades in different service positions, and including in the government. But we are not interested in any classified data. So that's one of the guiding principles of the project. We want to conduct scientific work that is based on new data that we collect with a new set of telescopes that we assemble and we have full control over, so that we know exactly what we are doing and that we analyze in a transparent way. So we have no interest in using all data that was partly classified. But on the other hand, there are a number of people that have good ideas about where to put the telescope systems and what kind of implications, if we do get interesting data, what kind of implications such data would have in terms of the public, the society, and we can benefit from their wisdom. And we include also Michael Shermer, who is a skeptic in the tent, the white tent that I established. And the reason is that we will be guided by scientific evidence. So irrespective of what the opinions of individuals are, the whole idea about scientific research is that once you have strong enough evidence, everyone would be convinced. And so if the evidence is inconclusive, you can be a skeptic. But once the evidence is conclusive, that will convince even the skeptic. That's the beauty of science. And vice versa. If we don't find anything, we are establishing a fishing expedition, and we might find only sardines. These are fish that are not particularly interesting. So be it. We will just report about that, and we will basically clarify that we haven't found anything unusual. And of course, we need a large enough number of telescope systems so that we cover enough of the sky and have a good chance of finding something. And the other thing I wanted to mention is there is this story about a fisherman that after spending several months in the sea, came back and said that he discovered a new law of nature. And that law of nature is all fish are bigger than 2 inches. So someone asked him, what's the size of the holes in your fishing net? And he said 2 inches. So of course, knowing your instruments, knowing the size of the holes in your fishing net allows you to make reliable statements. It's not a law of nature, it's just that some of the fish went through the holes. That's why we need to have a set of instruments that we fully understand, not a jittery camera in the cockpit of a fighter jet. That's not something that you know exactly what it did during the flight. And not relying on humans as detectors. That's the other thing. Throughout history, humans were testifying various things that they saw. That cannot be sufficient for a scientific publication. We want to bring this subject to the mainstream of science. And the way to do that is to use instruments that provide quantitative data and will convince the mainstream of science that, first of all, there are objects whose nature is unusual. And second, we want to clarify what these objects are. And, for that, we need to get a high resolution image of some of these objects and to track their trajectory and see if that can be mimicked by any human-made technologies. And of course, if it ends up being a bird that we see, then a high-resolution image of a bird would not be of interest to me. I will be glad to give it to a zoologist that will study. If it turns out to be a drone that is made in a foreign country, that would be of interest to some people in Washington, D.C., again, I'm happy to transfer it automatically to them because it's as boring as a bird is, as far as I'm concerned. But if it's something else, even if it's an unusual atmospheric phenomena, that's of value for science. And that's what we will try to find. And I can get into the details of what kind of instruments we hope to put together and what kind of approach we're taking.
About that, what of radar? Will you be using a radar component with these instruments?
Okay, so first of all, let me say the Galileo project has two branches. One is focused on identifying objects like Oumuamua. That was very weird. It didn't look like a comet or an asteroid that we've seen before in the solar system. It was the first interstellar object that was spotted near Earth in 2017. And we knew that it came from outside the solar system because it moved too fast relative to the sun. And the hope is that future surveys of the sky will find more objects like Oumuamua that are weird, that have anomalies, that do not look like a comet or an asteroid. And then we hope to design a space mission that will bring a camera close to such an object and take a close-up photograph, because a picture is worth 1,000 words, or in my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. I wouldn't need to write a book if we had a high-resolution image. And also study such an object in great detail, try to figure out the composition of the surface of the object, the reflectance of the object, the way it looks and moves and being pushed away from the sun if it is. So everything that we can get with instrumentation that is not too expensive is part of that branch of the Galileo project. And the second branch is identifying the nature of unidentified aerial phenomena. Those objects that were listed, there were 143 of them, in the report from the Director of National Intelligence to Congress on the 25th of June. And we want to figure out what these objects are, because apparently the government was unable to do that. And these objects were seen by multiple instruments. And I should say that the public is aware only of the tip of the iceberg, probably, because there is a lot of data that must be classified. I haven't seen it. I don't want to see it, so that my hands as a scientist will not be tied. As I said before, the Galileo project is about new data that will be available and open to the public, collected by instruments that we get off the shelf. The classified data was derived from classified instruments, and that's why it's classified. It's not so much that the data itself is a concern to the government in terms of releasing it. It's more that it would reveal the nature of the sensors that were used to collect it, which are classified. So we are basically solving that problem by buying off-the-shelf instruments, looking at the sky, which is not classified, by the way, because astronomers were looking at the sky for a long time. And the difference from astronomers is that in this project, the Galileo project, we will track objects moving close to us across the sky. Whereas if a bird flies above an astronomical observatory, the astronomers just ignore it. We will track it. And we will look at the entire sky all the time. We will not look at a very narrow patch of the sky the way astronomers do routinely. So when you ask astronomers and they say, oh, we haven't seen anything unusual, that's because their strategy for following objects that are nearby was not tuned for this purpose. They were not able to track rare objects that are flying nearby. And we are designing instruments for that purpose for the first time. And the Galileo project is the first team of scientists, of astronomers. We have almost 100 people by now in the project that came together and are funded to build telescope systems that would accomplish this task, scientifically, collecting scientific quality data. We're not talking about cell phone data, or, which is always fuzzy because the aperture on a cell phone is small. So I was asked, for example, at Harvard by the administration, whether this activity is part of my day job as an astronomer. And I thought about it and said, yes, I do think so, because we are collecting data with telescopes and interpreting it. And that's what astronomers do. That's what I did for decades. And the only difference is that these objects are nearby, they are close to us, but there is no limit to how close an object can be for it to be of astronomical interest. We look at the sun, we look at meteors, we look at asteroids, we look at comets. These are nearby objects. And as long as they give us information, potentially, about something far away, that's a fair game, and that's part of my day job. And the administrators agree with that. So I have a fund that is thanks to the donations of individuals. By now we have almost $2 million in it. The project started just a few months ago. And there are commitments for more funds from some individuals that are interested in giving us more. And my hope is to get 10 times more than that, the level of tens of millions. Of course, if we want to launch a space mission, that would require tens of millions to maybe hundreds of millions, depending on how ambitious we are. And for that, I hope to collaborate with either NASA or SpaceX or Blue Origins, just because we will learn something new. If we went after interstellar objects, even if those objects are nitrogen icebergs, a proposal that was made, or hydrogen iceberg, another proposal that was made by astronomers, or a dust bunny, a third proposal that was made by astronomers, even if it's of natural origin of this type, something that we've never seen before, which was all the proposals that were made were something that we've never seen before, we will learn something new by imaging it, figuring out that there are nurseries of these objects that we've never imagined, even if they are natural. So my point is, it's a win-win proposition. If we invest this money, we will learn something new, even if the origin is natural. And by the way, just recently there was the Astro 2020 Decadal Survey, and in it, there are projects that cost more than that, like $500 million to search for the polarization pattern of the cosmic microwave background that represents gravitational waves from the early universe. Now, so far there are only upper limits on that, and we will invest $500 million if we follow that path in a search for something that we may not find. We don't know if we will find it because so far we haven't found it. And my point is, we're investing $500 million in a search for something that we don't know exists. And at the same time, if we were to do this search for interstellar objects and getting more information about them, we know that they exist. We found one in 2017 that doesn't look like an asteroid or a comet that we've seen before. So we are likely to find more. And by investing even less money, we will learn something new for sure. And I think it's a win-win proposition. And I very much hope to partner with an organization that can fund the space mission for that purpose.
In 2016, I woke up one day and said to myself, I need a YouTube channel. I expected a subscriber, which I'd have made videos for often. Clearly, I underestimated that number. Then 3 years ago, I asked many of you to come along and enjoy a new experience, Event Horizon. And since then, we've had amazing conversations with everyone from X to Z. Now I'm proud to announce the next steps for the show, but before I do, I'm a YouTuber, and this content will always be freely available here and nothing changes. But people have asked for other listening options, particularly as an audio-only podcast. Well, it's here. We are expanding Event Horizon and my channel to multiple podcast platforms, namely Apple and Spotify, and YouTube memberships, to give you more ways to enjoy all of my content. Now let me be clear, we will always be on YouTube with new episodes released every Thursday, and the usual videos on the JMG channel. Nothing there changes. These other platforms include Apple Podcasts, Spotify, as well as any podcast app that supports secure RSS feeds, and the new YouTube membership, which gives you the same access. For $5 a month, you get early access to new ad-free episodes, usually weeks early. You'll get the full audio archive of both channels, Event Horizon and my original channel, as well as bonus podcast-only episodes and special sleep-focused tracks. And for those asking about audiobooks, premieres of my audiobooks will be on there first, but will eventually premiere here on YouTube for free as well as me reading other books and short stories. Imagine if I read Frankenstein. Or how about this quote? "Speak not to me of blasphemy, man. I'd strike the son if it insulted me. Look ye, Starbuck. All visible objects are but as pasteboard masks. Some inscrutable yet reasoning thing puts forth the molding of their features. The white whale tasks me. He heaps me. Yet he is but a mask. 'Tis the thing behind the mask I chiefly hate, the malignant thing that has plagued mankind since time began. The one thing that maws and mutilates our race, not killing us outright, but letting us live on with half a heart and half a lung."
John, that was Gregory Peck, not Melville.
And don't want the background music? You can choose between music and non-music versions of Event Horizon. Though not JMG, as I had no idea I'd be successful on YouTube and didn't save the original audio files.
Of course you didn't, John. You humans don't often anticipate future developments.
Oh, and I almost forgot. There's going to be something new and exclusive on this service. How about an entirely new show hosted by the one and only Erin Knight? She sounds uncannily like Anna, which I'm hoping distracts Anna enough to forget about my kale diet and I can get back to cheeseburgers for a while.
That's right. Erin is going to host a new show, the Accretion Disc. And guess what, John? You're the first guest.
I don't know how to be a guest. What are we going to talk about?
Oh, I don't know. Probably your book.
If you join now, you get immediate, early, ad-free access to a new interview with SETI co-founder Jill Tarter, as well as the first bonus podcast episode with a surprise guest. And the first 100 to sign up also will get a free PDF copy of my book, The Salvagers. Sign up now by clicking the links below to your platform of choice. If you would like some help or how to sign up on one of these available apps, click on the chapters below and Anna can walk you through it. To use a podcast app other than Spotify or Apple, you can do so by signing up one time on Spotify and copying the secure RSS feed into the app of your choice. Anna can help you with all of this by following her walkthroughs in this video. Thank you for coming aboard this new journey, but remember, nothing here on YouTube changes. You'll get the same content you always have. And actually even more, since I'll be releasing more frequently these days. By signing up as a member, I will be able to provide ad-free podcasts which will allow me to focus on writing new scripts and interviewing more amazing guests here on YouTube. Thanks for listening, and thank you for being a part of this ever-growing universe in which we live.
Who the is Erin Knight anyway?
What? No infighting!
To sign up on Spotify on your browser, click the link below for Anchor. Fill out your information and follow the prompts. Accept the terms and sign into Spotify, or copy your private RSS feed and paste it into any apps that support secure RSS feeds. If you're on mobile for Spotify, follow the same steps. Click the link below for Anchor and follow the sign-up prompts and connect to your Spotify account. You can copy your private RSS feed on mobile and paste it into any app that supports secure RSS feeds. To sign up on Apple Podcasts, click the link below and follow the prompts until you open the show in the Apple Podcasts app. Once there, click Try John Michael Godier free. Double-click or do whatever your phone's screen prompt says to sign up through Apple. And that's it. You now have the show on Apple. To join on YouTube, click Join, next to where you've already clicked Subscribe. You've clicked Subscribe, haven't you? Once you hit Join, follow the prompts from YouTube to sign up and get immediate access to the same podcast bonus features and early ad-free audio episodes. Thank you for your continued support.
We should get into responsibility and the question surrounding that. If we have poo-pooed and ignored and downplayed the presence of an alien civilization in our atmosphere with us for the last 70 years, and it turns out that Galileo finds compelling evidence, we won't call it extraordinary, we'll simply say compelling evidence of the presence of an alien civilization on this planet with us, then a ball has been dropped bigger than any in history, because it could simply be that if that's the case, then we have to start looking at Fermi Paradox solutions like the zoo hypothesis, or that they're here to police us and keep us from developing certain technologies and things like that. So to find such a thing, or even find a hint of such a thing, all of the awards and all of that, the Nobel Prizes get melted down because we have dropped the ball on an unbelievable scale if the UAP are of alien origin, or even just something we haven't thought of yet, whatever they may be.
I should first say that the reports of the past may be a mixed bag. There may be, maybe most of them have some mundane explanations, but that's not really the point. It's sufficient to have one unusual object of extraterrestrial technological origin for it to have major implications for our future. And we have a subgroup within the Galileo project that is discussing the societal implications. Currently, we are not prepared to respond to that. The fundamental question is, what is the intent of any equipment that we find? And my thinking is that the biological creatures like ourselves are not really designed to survive in space. We were selected by Darwinian evolution to live on the surface of Earth. And if we go to space within a year or a few years, unprotected, then our brain will be damaged at a very high level from cosmic rays that will impact us, and we just wouldn't survive. And just protecting us is a major task. Moreover, the travel between stars will take, if we use existing chemical rockets, will take 50,000 years to the nearest star, and much more than that, millions of years to other stars. And we will have to go through many generations of people on any spacecraft that we send. So I don't think biological creatures are really suitable for space travel between stars. And the solution is obvious. We are now developing artificial intelligence systems that drive cars. Within a decade, they will outsmart us in many ways. And you can imagine sending AI astronauts to space. That means sending a system that is autonomous, doesn't need any guidance from us, as if we are sending our technological kids. I mean, we can train them at an early phase, just like we educate our kids at a young age, and then you send them to the world, and they learn from experience. In the case of AI systems, machine learning. And then you just provide them with your guiding principles, with a blueprint of how you want them to behave and what goals you want them to achieve, and you hope for the best. With kids, you don't always get what you want. Sometimes they do things that you do not approve, and the same will happen with AI systems. But the idea is, since they're made of electronics, they could survive in space for millions or billions of years. So AI astronauts, the way I see it, is really the future, because also the communication across interstellar distances takes a long time. You cannot ask them to wait for guidance from the senders. And so if we can imagine sending AI astronauts that will be autonomous to interstellar distances, perhaps another civilization that is slightly more mature than we are technologically have done that already. And if you equip those systems with 3D printing, they could in principle replicate themselves using the raw materials they find on other planets. And then you get to a situation where you can fill up the entire Milky Way galaxy with probes that have AI systems on them within a billion years. And most of the stars in the Milky Way formed billions of years before the sun. So the fundamental question is, do we live in a reality that includes those probes near us or not? And if these probes are small, we wouldn't have detected them easily. And so the only way to find out is by searching the sky. And that's what the Galileo project aims to do. But if I had to guess, I would think that we're dealing with AI systems, if they are intelligent. And of course, to interpret their intent, we might need our own AI systems. And it's sort of like relying on your kids to figure out the meaning of content that you find on the internet, because they're more computer savvy. So we will use our own AI systems to interpret their AI systems, and they might outsmart us. And I'm just hopeful that we will not be in a situation similar to the Trojan horse story, where the citizens of Troy were happy to bring in the Trojan horse into their city, and we all know the consequences.
That's astonishing. Now, we would have to, in order to interpret an alien artificial intelligence within our star system with us, we may have to invent our own artificial intelligence in order to understand the alien artificial intelligence. But that gets scary, because what if our artificial intelligence sympathizes with the alien and not us? or it launches itself into space, figures out a way to do that, and goes and joins the alien artificial intelligence, and they just go off into the galaxy together, and we never know the answer to anything. And
well, it's just like having your kids marry someone and leaving home. That's I wouldn't worry too much about it. But I'm primarily frustrated by the response of the scientific community to this subject. But I'm hopeful, I'm optimistic, because I think that in the not too distant future, AI systems will start analyzing scientific data. And when you start having AI scientists replace human scientists, then I'm much more hopeful, because they will not be necessarily swayed by their prejudice, by their arrogance, by their ego. They would, if they see an object that does not share the qualities of comets or asteroids like Oumuamua, but shares the qualities of 2020 SO, that is an artificial object that we produced, a rocket booster that we produced, they would say, that's interesting. Look, there is an object in the sky that behaves like 2020 SO that we produced, but doesn't look like comets or asteroids we have seen before. Therefore, it could be artificial in origin. Let's collect more data. That's the response I would expect from an AI system that looks objectively at the data without prejudice. Instead, what do I hear from my colleagues? A colleague of mine that worked on rocks in the solar system for decades heard about Oumuamua, and the first thing he said was, Oumuamua is so weird, I wish it never existed. And that shows to you the weakness of human nature. But if an AI system would look at the same data, I'm much more hopeful. So when science will be handled by AI systems, I very much hope that its rate of discoveries will be advanced. And I participated in a forum with a relatively young person who said that he is quite worried about the future use of AI systems because they may behave in ways that we do not approve, they may deviate from what we hope. And I said to him, well, I raised 2 daughters. You are speaking just like someone who didn't have kids, because when you raise your kids, you never have a guarantee that they will behave the way you want them to behave. You are just trying to educate them at a young age and then send them to the world. And of course, in some cases, they don't do the right things, but we should be relaxed about these technological kids of ours, which I call AI systems. We should just try to educate them well early on in their evolution and then send them off to the world. And I'm hopeful, just like I'm hopeful about the young generation of today, even though they do things that are different from the things we did when we were their age. I always think that they would do better than us. And the same is true about AI systems being scientists, being astronauts. And I have no problem whatsoever thinking about a future in which we send technological monuments into the universe that will carry the flame of our existence. And these would be AI systems that will go places. Just to give you an example to contrast that with what we did so far. So far, for example, we sent the New Horizons spacecraft to Pluto. And on the spacecraft, we put 30 grams of ashes from the body of Clyde Tombaugh, who discovered Pluto, to commemorate his discovery. So to celebrate the person, what we did is take his DNA and burn it up and put the ashes on the spacecraft. Now, the ashes are no different from cigarette ashes. They carry no genetic information whatsoever. And we put it to celebrate that person. If an extraterrestrial finds this, they would laugh at our primitive ritual of burning up the information about a person that we want to commemorate. That makes no scientific sense whatsoever. They cannot reconstruct Clyde Tombaugh from these ashes. If we wanted to maintain some memory of Clyde Tombaugh, we would put his DNA in electronic form on the spacecraft, or we would put a stem cell on the spacecraft. And I asked the principal investigator of the New Horizons program, Alan Stern, who is a member of the Galileo project, about it. And he said that putting a stem cell on New Horizons would have been a bureaucratic nightmare in NASA. But nevertheless, my point is, it would have been better to put an electronic record of Clyde Tombaugh on the spacecraft. Now, my hope is, in order not to embarrass ourselves by the extraterrestrials finding New Horizons, first, not to give them a bad impression at first sight, we should send a spacecraft that moves faster than New Horizon, that will catch up with it and go farther than New Horizon, that will carry, for example, an AI astronaut. And then they will think good things about it and say, oh, well, they seem to be like an intelligent species out there on Earth, before they get the ashes delivered to them.
Perhaps, I think somewhere in someone's closet, as I recall, there sits Einstein's brain. And so if we were going to send somebody, a representative of humanity's DNA out, perhaps it should be Einstein. Any thoughts on that?
I would be happy with that choice. But as I said, my hope is with the future. I always think that the future can be better than the past. So even though we are very proud of Einstein, my guess is that in the future we will have an AI scientist that would do better than Einstein, in the sense of using an unprecedented amount of information that Einstein's brain was not able to digest. Using that and finding correlations and patterns in the huge data set that provide us with a new law of nature or a new understanding of reality. That's something that AI systems might be able to do that humans were never able to do, because they cannot process such a huge amount of data in their brains. So my hope is that in the future we will have a super Einstein AI system, and it would make more sense to send that on a spacecraft, only for the reason that not to brag about our accomplishment, but also to sort of send an image of what we have here on Earth that is flattering to us, that implies that we existed and we achieved an important milestone, that it's not just the biology that came out of a soup of chemicals on one habitable planet out of so many. We created a completely new thing out of the materials we found on this Earth that exceeds our abilities, that can do better than any human. And to me, that would be the best monument that we can send to space. At Harvard University, I see very often statues or paintings of past presidents or deans or important people that wanted to preserve a physical image of the way they looked during their life, as if that would signify something important and will maintain their longevity, maintain their memory. That all makes very little sense, because within 1 billion years the sun will boil off all the oceans on Earth and burn up the surface of Earth. So all of these monuments will go away, and probably we would have no problem with it because we are more intelligent than it. And we would feel proud of ourselves, we found something new, but it doesn't really threaten our ego. But imagine the same rover bumping against the wreckage of a spaceship that represents technologies that we do not possess. That would be a blow to our ego if we find that. And my point is, we would much rather, if you ask most scientists, they would much rather not confront that situation. Because if you look at physics over the past century, by doing laboratory experiments, we discovered the laws that control the behavior of elementary particles like electrons, atoms. These particles are just slaves to the laws of nature. They do exactly what the laws tell them to do. And we found these laws of physics that gives us a boost to our ego, because not only we understand how these particles are behaving, so that shows that we are very intelligent, but also these particles have no free will. If someone tried to formulate an equation that will forecast what we will do in the future, and we knew about this forecast, we would behave differently. We would violate the prediction of that equation. So we feel that we are superior relative to these atoms and electrons because we are able to decide. We have some sense of free will, some consciousness that allows us to decide in a way that is not necessarily predictable. And so doing physics is a boost to our ego in two ways. And then we also find microbes, we feel superior relative to them because we're much more intelligent. We also feel superior relative to animals. We eat them, we put them in cages. We feel superior relative to them because we feel that we are much more intelligent. And the next level is that some humans try to feel superior relative to other humans. You find that throughout human history, and that's the worst disease. Because if you look at the Second World War, the Nazi regime triggered the death of 75 million people. That was 3% of the world population in 1940. It's 20 times more than the number of deaths triggered by COVID-19. And that was just the result of a group of people trying to feel superior relative to other people. So what you find is that the ego plays a central role in human activities, including in the academic community, including in science, which is very unfortunate because in the context of science, we are missing on discoveries as a result of that, by people pretending to be experts, ridiculing any discussions on things that they don't know the answer to, and dismissing anomalies because anomalies raise doubt about their knowledge. And this is not the way that science should be handled. And my hope is that AI scientists would do better.
But to run a scenario by you, and this is where it gets scary. If we find that this civilization that has sent a robotic entity across space-time to get here and went through all of that trouble, there must be a motive to do that. Now, this could be something so simple as science. They're curious. They're anthropologists. They're like, well, we see evidence of an advanced biosphere on this planet, so we're going to send something there. It's starting to exhibit weird oxygen levels and things like that. But maybe eventually, and perhaps it's the rule in the universe, that produces a civilization. So they just put a monitoring probe to just simply learn. But it could also be something more nefarious. And it could be that the moment you create that AI to try to figure out the AI that's sitting in your solar system, you've committed a crime according to the laws of the civilizations of the galaxy that they have agreed on. So you have a police action scenario where the whole presence of this thing is to monitor, but not have contact until you get its attention, just like the police. You sit on your porch, the police pass by. But the moment you try to steal your neighbor's barbecue, it intervenes. So if we were in that situation where it actually serves some sort of function like that, and it is far superior to us technologically, That means the zoo hypothesis is automatically the solution to the Fermi paradox. Do you fear that, or do you say we're nowhere near close enough to even know if that's the case, and we should just see what comes because it's reality, whatever it is? Right. Do you see that, or do you think, and again, that deep-seated fear, do you think people fear this idea of a more advanced civilization being that close?
Yeah, so I wrote an essay about that in Medium recently about the protocol and for dealing with a discovery of, let's say, AI systems nearby. And, you know, we don't know their intent, and it's similar to cracking the Enigma code, for example, during the Second World War by Alan Turing. And, you know, it may be a task of linguists, of AI systems, figuring out the intent of those. But my approach is we should first approach it in a passive way, just collecting information about those objects in a passive way, not trying to engage with them, just seeing what kind of information they are seeking. How do they respond to human actions on the globe? And then we need to have a discussion whether to engage with them, whether to communicate, whether to do something. And of course, that would have to weigh in all the implications of engagement. But I do think the first approach should be passive. And indeed, the Galileo project will use only passive sensors. We will not transmit even radio waves. We will not do the standard radar search. So we will have an optical telescope that looks at the entire sky with a fisheye camera. We will have infrared sensors that cover the entire sky all the time. And we will have radio sensors that detect any radio transmission or any reflection of radio waves that exist otherwise of objects of interest. And an audio system that detects any sound waves coming from these objects as they move in the atmosphere. So all of this will be collected in a passive way without sending anything in the direction of the objects of interest. And I think that should be the first approach. And of course, what we do afterwards should be an international matter. It's not a matter of national security if the label doesn't imply that these objects were made here on Earth, or if they behave in ways that we cannot reproduce with our technologies. So this is a very important question that you brought up, but I think we first need to find that such things exist and understand what they're doing, or at least what kind of information they're seeking, where are they, and what kind of response they have to what we do here on Earth, unrelated to them. And then we can discuss it and make a decision. It has to be decided by an international forum.
But that in itself could have a benefit, because Ronald Reagan once pointed this out. And as I recall one anecdote, I don't know if it's true or not, but he asked Gorbachev, if the United States got attacked by an alien civilization, would the Soviet Union back us? And he said, no doubt about it. So when you have a global security threat, then hopefully everybody comes together and starts putting aside some differences. And right. I think that's one thing that we could say with certainty that we would do. If we had an outside threat, we would suddenly become the human species, and we would slow down on the petty squabbling of countries. Do you think that's the case?
Well, I'm an optimist, and my hope is that if we find that an advanced civilization is out there that is more advanced than we are, more intelligent than we are, that there is a smarter kid on the block, then all of the small differences between us will become meaningless. And trying to feel superior relative to each other, to other humans, would make very little sense. The Nazi doctrine will make very little sense. Here is a civilization that's far more advanced than us. My hope is we will treat each other with respect as equal members of the human species. That will be the first effect. So the first effect will be on how we deal with each other within the human population. And then, of course, there is the question of how to communicate with them. And my view is we will learn from them, because they might have answers to questions to which we don't have an answer. For example, we don't know what happened before the Big Bang. We don't know what the dark matter is. We don't know what's inside a black hole. So to give you an example in the context of the Big Bang, of course, there are religious scripts that say the universe was created by some divine entity. And then there are scientific ideas, such as that the universe was created out of nothing from a fluctuation of the vacuum, or that it's a cyclic universe. There was an initial phase where it contracted, and then there was a bounce and it expanded, and it will contract again and expand again in many cycles, infinite number of cycles. And there is another possibility that I pointed out in a Scientific American essay recently, and that is, it's possible that once we develop an understanding of how to unify quantum mechanics and gravity, we will understand how to make a baby universe in the laboratory. And it's possible that our universe was created in the laboratory of an advanced scientific culture. And in that case, if that culture created our universe, and in our universe there is what I call a type A civilization of that quality that can create baby universes, it could lead to another universe being created, and you can have multiple generations, one after the other, having babies that make new babies and so forth. Just like humans, just like a chicken lays an egg, and out of the egg hatches a chicken, and so forth, and you can go through those cycles indefinitely. So it's an interesting possibility that perhaps our universe was created in the laboratory of an advanced civilization. And in that case, what we call God in religious scripts is actually an advanced scientific civilization. So the two concepts, one of which is religious, and the other, which is a unification of quantum mechanics and gravity in the context of the future of science, the two may come together. It's true that someone created the universe, but it was done in the laboratory of an advanced scientific culture. And of course, the way to find out is if we ever meet such a culture, which I call type A civilization. You see, we are type C because we are just harvesting sunlight, whatever nature gave us, whatever the astrophysical environment gave us, we're using it. And in fact, we might be even called type D civilization because we are destroying our habitat. We don't preserve our climate. So our grade is somewhere between C and D, I would say. And then you can imagine a type B civilization that creates a platform that makes it independent of its host star. So it can create anywhere. It doesn't need a host star in order to survive. So it has a nuclear reactor that makes its own energy and maintains a habitat that civilization can live in, irrespective of whether it's next to a star. So that's type B, that is independent of the astrophysical circumstances. And then type A is a civilization that can create the conditions that led to its existence, including creating a baby universe in the laboratory.
Now, my last question for you, Dr. Loeb, is this. Now, you're going to appear with Bill Nelson soon at a presentation, and there's all kinds of talk by Nelson, but also many others. The SETI Institute is putting on a forum soon regarding whether UAP are worthy of scientific attention and things like that. Now, you once told me early on that you were going to throw yourself on the barbed wire regarding this question, and like a soldier in the Israeli army, you were going to open the way for others to push through. Do you think that the indications now is that you were successful because there are more people talking about it than there ever was before?
So the key is not people. As I said, I don't care how many likes I have on Twitter, and I don't use humans as detectors because humans are often motivated by other reasons. They are motivated by their ego. They have wishful thinking. They do not always report what is right. And the way to figure out what reality is like is to use instruments that provide us with quantitative information. And that's the scientific method that Galileo Galilei founded, that philosophers at his time resisted because they thought they have a good idea about the sun moving around the earth. And all of modern science was based on Galileo's approach, even though he was put in house arrest at the time. And today he would have been canceled on social media. So my point is, if we follow the scientific method that led
to all the advances that we benefit from in our daily lives, including the navigation systems in our cell phones, that those rely on Einstein's general theory of relativity, which was verified through observations of the universe and the solar system and many other, and most recently gravitational waves from black holes that collide at the edge of the universe, and as well as an image of the shadow of a black hole. So the point is, we can learn about reality, new things, if we pay attention to evidence rather than to our prejudice, rather than to our notions. And it's a learning experience. And the key for us to learn is to stay modest and recognize the fact that everything we know is just an island in an ocean of ignorance. So if it's not about us showing off that we are smart, then instead of being preoccupied with extra dimensions, the string theory landscape, the multiverse, all of these ideas that are constructed such that whoever writes about them appears to be smart, just let's forget about those. These ideas have no verification, have no substantiation by experimental data. Instead, let's work on questions that we can address by collecting more evidence, such as, are there objects that were manufactured by advanced technological civilizations within the orbit of the Earth around the sun? This is a question that we can address with hundreds of millions of dollars, get a clear answer to, at least in terms of explaining objects that we already found that do not resemble rocks. And if we engage in that, there would be much more excitement about science. Young people are really excited about it. I get thousands of emails every week from people that would like to engage in this question, and some of which are worried about the prospects, if they are scientists, about the prospects for their career. And I also get a lot of donations from individuals that feel that this is an inspiring question, an inspiring vision that humanity should pursue. So my point is, we will bring more funding to science, and we will engage the public in a more meaningful way if we were to pursue this question. And by the way, it will have a huge impact on our future.
Well, it's worth noting that the public is far more interested in the question of alien life than most scientists are these days. Thank you again, Dr. Loeb, for appearing with us. We're out of time, but we'll do this again sometime soon as the Galileo project forms up.
Thank you so much, and I will be glad to report about anything we find.
Yep. Good luck.